A3 now. This is the first unit, which is the clutch. Want to preface this by explaining a lot of the stuff we're going to cover is about some of the symptoms you'd have if there was a clutch problem, but a big part of it is just being familiar with the different designs. Typically, the ASE doesn't ask a lot of questions about different designs of the clutch. They might um, they might throw in like a dual mass flywheel, but mostly it's going to be generic clutch questions. If it has to do with whether it's cable actuated, they'll say that. But for the most part, it's going to be hydraulically released clutches. And then a lot of these are procedures towards the end. It's a lot of summary on procedures. And the reason for those is just to get you familiar with what's a yes and what's a no. Um, but there's additionally like videos that I've been making for for example, how to measure run out of a flywheel. So those videos are going to be a lot more valuable to you to actually do the work, but they're at least laid out in here so that you understand um, kind of the ASE concepts too. Okay, so we jump right in. So the purpose of the clutch, it's a mechanical device. It's located in the bell housing. It allows to disengage. They'd say engage and disengage engine from the transmission. So like if we're coming off of automatic, you guys would know that was pretty much the job of the torque converter. You'd come to a stop, the torque converter being a fluid coupling would allow the engine to continue to spin while the transmission input shaft would stop because the vehicle was stopped, right? So same type of an idea. That was the main purpose of the clutch. And then how we control that, you all know, controlled through foot pedal. It's going to possess a series of different components. So when someone says, I need a new clutch, you could take that as just that. They need a new clutch disc. But if we're going to do a clutch service, we're more than likely going to be replacing multiple components and definitely cleaning up multiple components and definitely inspecting all the components. So we're going to talk about all the different little parts and pieces. Um, and then generally an automatic transmission does not use a clutch, but definitely not a manually operated clutch. So one version of an automatic transmission that does use a clutch would be like a dual clutch, but we don't operate that. A computer controls those, so the manual is the only one that's going to actually have that clutch pedal requiring the driver to do the thinking and the action. All right, so just a preview on the parts. So when we say the clutch, generally we're talking about all this stuff in here. And you might even include the flywheel. So it's not a flex plate anymore. It is a true flywheel because it has a friction surface and it has a lot more mass. It's a lot heavier than a flex plate. In automatic, we don't need a flywheel. We just need a flex plate because the torque converter and especially the fluid inside becomes the mass. We don't really need anymore. Right. But if you look, the disc, that's the main wear item right there because that has the friction material on it. So if a clutch is worn, a lot of times by default, we're talking about a worn, the lining friction material on the disc is going to be worn. But the thing is, it's kind of like brake pads and rotors. If you've worn your brake pads out and the friction lining has been worn down year after year, miles after miles, you've probably caused, some issues on the rotor. So this is equivalent of kind of like the rotor, but this is only one side of the surface. The other side is actually in the clutch cover, which a lot of times we'll call like the pressure plate, right? So there's two surfaces there when we do clutch work we're very concerned about. Generally speaking, the clutch cover or the pressure plate, that's going to be replaced as part of the kit. So if you order a clutch kit, it's going to most likely come with everything from the disc, the cover, the release bearing. That would be like your basic kit. A good kit may come with it'll probably come with a pilot bearing. We come back to that. They do have kits that come with a flywheel, so it tends to vary. But if you were to roll right into the Toyota dealership parts department, whether the front counter or the rear counter, and you just said, "Oh, I need a new clutch for my vehicle," they can, if they order a clutch, they'll probably get you just the disc, which would not be really proper procedures, right? It's kind of equivalent to like a pad slap, right? the pads are worn out, so you just slap new pads on there. They'll probably work. You might get some issues though. The rotors may already be warped, and so you might replace the pads. Obviously, that's not going to address the pulsation, and the customer doesn't typically understand why the pulsation occurred. They just think it needs new brake pads, right? So similar with a clutch, a lot of our issues are not necessarily related to the disc. So it's best procedure to replace the clutch kit, which may or may not be available OEM. A lot of times from OEM, they want you to get individual parts and pieces. Okay, and then additionally, we've got the fork and we got the transmission, and the fork has a pivot right here. And that stuff we need to not only inspect, but a lot of times we'll need to, like, there's a couple lubrication points on there. So this would be one. A lot of times there's another right about in the center to do the actual pivot. And then we may put a little bit of lubrication right here where that release bearing's gonna turn. So we got quite a bit of little service work to do. When we do a clutch, we don't just slap the disc on there. Cool. So we'll jump in. Again, we wanted to disconnect and connect the engine to the transmission, but we want to be able to do it what we call progressively. So it's not just on or off. If you start to push the clutch down, it should kind of gradually release it. And then when you go to engage it, right, engaging the clutch, for clarification, means you're releasing the pedal. As you release the pedal, the clutch becomes engaged. Okay. By default, if you have, let's say, you take the clutch release mechanism, whether it's linkage, whether it's cable, whether it's hydraulics, if you take that system out of the picture, by default, your clutch is applied. So your clutch is squeezed by that pressure plate, which has springs, and they vary. There's several different designs, right? But all of them work the same, where they squeeze the disc up against the flywheel. So understanding that's going to be important, because generally problems with the release system, hydraulic issues like air in the line. That's actually what I have on this Jeep right here. It's the main reason I haven't delivered this thing yet. I did a whole bunch of service on it. One of the things being I changed the hydraulic fluid, so brake fluid and clutch fluid. And when bleeding a clutch can be a little bit tricky. So just try to just loosen the bleeder and let it gravity bleed out, and kind of like bottle feed the rabbit feeder type of thing. But one way or another, now it's got kind of a spongy pedal. By default, the clutch is engaged, so the release system releases the clutch, right? So as soon as we start having a problem like a clutch is not releasing all the way, we want to look into the release system. So that's exactly what I got with this one. In the release system, I push the clutch pedal all the way down, and it still grinds a little bit going into reverse. And you can tell the very first part of the clutch pedal is just it just feels a little loose. And I attribute that to air being in there. And the reason I'd say that is because it was good until I opened up the bleeder and got new brake fluid in there. So somehow I got air in there. Right. So considering that, when we think about the clutch, just remember the disc is squeezed by the pressure plate by default. Then we do all this additional things, all these additional components, the clutch master cylinder, the clutch slave cylinder, the clutch line, the clutch cable, the clutch whatever, all that stuff is there to release it. Now, let me clarify why I say that. If you were to ask a person, let's say you're talking to the customer, and you'd say, okay, well, when does this noise occur? Noises are pretty common in clutches. And they'd say, oh, when I engage the clutch. You need to be on the same page. I just about guarantee you, I bet you 9 out of 10 times, maybe more, when the customer says they engage the clutch, what they mean is when they engage the clutch pedal. Okay, when you push the clutch pedal down, that's disengaging the clutch. Okay, the clutch was shown on this page, right? So by default, that disc is squeezed by the pressure plate. Boom. Okay, so if you don't touch the pedal, I promise you that clutch is engaged. If you push your pedal down, now that clutch is disengaged. Right? So some of it's just terminology here. Okay. And then as we get further in, we're going to introduce some new words. So sometimes it's more clear to say depressed. And you're like, depressed. Does that mean it's not pressed? So if you hear the term clutch pedal depressed, that means it's pushed down. All right. So we may do some of this from the perspective of the pedal. We may do some of this from the perspective of the actual clutch. So it could get a little confusing, I'll admit. So I want to make sure everybody's really square and clean right there. Okay, and then that's kind of what it's saying. It's going to allow us to disconnect the transmission from the engine to shift gears, like particularly when we're accelerating or decelerating, right? We pick a gear and that gear is great, but then you've sped up enough where you need a different gear, or you've slowed down enough where you need a different gear. One of the parts in shifting, when we get into the actual transmission, the manual transmission transaxle, the first step in performing a shift is to disconnect engine power. The way we disconnect engine power, we depress the clutch pedal, which disengages the clutch, and then there's no torque going through the input shaft. And then click, 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 we can shift gears. Cool. So there's some basic stuff. Now, obviously, I pick on my own people, okay, so that way you guys aren't offended. They used to call this a millennial theft detection system. So you go to park your car out there. Let's say you got something cool, like let's say a Supra, or in my mind, I was thinking Camaro because I am on like some Camaro Facebook groups, and people will be getting those cars stolen all the time, right? But they're way more common to steal the automatics. And they kind of joke around saying like, oh, the thief came to steal the car, and they looked in there and they saw that third pedal, and they're like, nah, forget this. I can't steal that. So people were going crazy with all the kill switches and security systems and the Viper alarm and the whatever. And one of the more effective things was just to have it be a manual, and they wouldn't get stolen. It's kind of funny. So you look at this, obviously you got gas and brake. You better know that. And then you got the clutch pedal. This clutch pedal's sole purpose is to control whether that clutch is engaged or disengaged. So again, when I say depress the clutch pedal, I'm talking about push this down. Cool. Or I might even just say pedal, put the clutch pedal down. But the ASE a lot of times will describe it as the clutch pedal has been depressed. Depressed does not mean depressed, which means released. I don't make the terms. I'm just telling you. I'm just interpreting for you. Okay. I can assure you, depressed means down. Cool. Okay, and then just to make sure you understand, in an automatic, remember we talked a lot about clutches. They're wet clutches. So in a manual, we're talking about a dry, exposed to air, living in the bell housing clutch. Similar materials, but one's dry, one's wet. A little bit, probably a little bit different material, but a lot of times the way that we're applying and releasing an automatic would be with hydraulics, whereas with a dry clutch, the clutch we're talking about, that's going to be like pedal, right? But there are some vehicles that use this type of a dry clutch right here on an automatic transmission. So if it's a dual clutch transmission, it'll actually have a disc like this on some of them. And there will be a couple different shafts it's got to connect to, but there will be actually like an ACE, a three-phase AC motor to engage and disengage this. And the computer controls that. The computer controls the 12 volts in ground to apply or release that clutch, all from, right from the computer, so the driver doesn't even know. So there are clutches that look like this that we don't have to control with a foot pedal. But a lot of the dual clutch transmissions, they'll actually use wet clutches too. So in the dual clutch, it'll actually look like a manual, but the way that the one, let's say the odd gear shaft or the even gear shaft is applied is actually with wet discs, which means we're applying and releasing those with hydraulics, just like in an automatic. So mostly our focus is going to be on your traditional manual transmission, got a clutch pedal. But there are some other clutches out there. They're just not super integrated with the ASE. I don't think that they can figure out whether a dual clutch should be in manual or an auto. So they tend to be pretty minimal on the dual clutch questions, just so you've been introduced. They could have either one. Okay, and then the amount of torque a clutch can transmit depends on the amount of friction between the clutch disc and the mating surfaces of the flywheel and the pressure plate. So remember, it gets squeezed like a sandwichy. So the clutch disc is in the middle, being squeezed by two pieces of metal, one of them being the flywheel, the other one being that pressure plate or the cover, which they interchange terms sometimes. All right, but then the amount of friction could depend on coefficient of friction of the clutch disc lining, the facing, right? So it's kind of like brake pads. You can have semi-metallic, you can have ceramic, right? There's different types. They're gonna stop a little bit different. Well, same with this. From the factory, they're using one type. If you go to put, a better clutch, like I'm gonna bring this one up in a little bit. I had a friend, I say loosely friend, it's one of those guys that you're friends with kind of by default because he's friends with someone you're friends with, even though it was kind of a ding dong, you know what I'm saying? So he went and got a purple clutch. He went on a magazine, internet was a thing, but like it was also common that you'd get like a magazine, like a Jegs magazine type of thing. Got a magazine, they were talking about this purple clutch, so he got a purple clutch, and the car had quite a few issues, but just when you would engage it, it was like remember, progressive smooth engagement like from the factory. There was like you let the clutch pedal up and all of a sudden bang, that sucker was engaged. It was rough, it would kind of buck, and he'd be like, oh, there's something wrong with this clutch, and it was sort of like, no, dude, you ordered like the race clutch. When you go with the race clutch, they're going to have different coefficient of friction. They could have different, also, they could change a whole bunch of stuff. Okay. So we want to break some of this stuff down right here, like some of the things that the factory does and why they do it. And why I would suggest if the customer is not specifically asking for some sort of a race clutch, I would absolutely go with the factory one. The factory one was designed to handle the amount of torque that vehicle made, plus a little bit more, because engineers always, build in a little safety net, a little buffer, if you will. So when they figure out how much friction it needs, again, it's coefficient of friction of the lining, the diameter, the number of clutch discs in the clutch. So let's pause right there. In the transmission room, there's a very interesting looking clutch, and it's actually got two discs, and that was off of an Acura NSX. And I don't think that was factory. I don't think they come that way, but this was something that, was like in a performance shop around the corner from the school. And a former student, what they basically hired him to do is do automatic to manual NSX swaps. And so he became like the go-to clutch guy on NSXs. So he brought that clutch in. It's a pretty cool one. It's literally got two discs. So if you think about it, you got like the flywheel, a clutch disc, another piece of metal, and then a clutch disc, and then the pressure plate. And you'd actually have double the surface area because you've added two discs. So that'd be more high performance, but they could do it from the factory. For example, tractor trailers, those have twin discs. Those are two dual disc clutches. They need a lot of holding capacity because that diesel makes a lot of torque, and they're going to be towing a lot of weight. So they need to be able to transmit a whole bunch of torque, especially taking off down in first gear. First gear with a big gear reduction will make a lot of torque, remember? So they could have a lot of different designs, but if the manufacturer's done it, they've done a lot of research and development. They're going to have it really dialed in. I'm just not sure that I would slam a dual, a twin clutch disc in a vehicle unless it really needs it. But if it came with it, it'll probably work pretty well. Then another thing right here, total spring force clamping the parts together, and you're like, what? Well, remember that pressure plate basically it functions as a spring. Okay, so the metal surface that's squeezing the disc, that's being squeezed by a spring. So if you could just picture a big old coil spring back there, that's going to squeeze it. If the spring is stronger, it's going to squeeze it tighter, and that's going to allow it to transmit more torque. Can anybody think of one negative If you wanted to be able to have a clutch handle more torque, can you think of one negative of having it handle more torque by putting a stronger spring in there? It's one negative.
It's more difficult to drive day to day.
Exactly. So you get these race clutches, right? And then you go to push the pedal. It's like, holy crap, you can have one big leg right here. You can have like a big left leg and like a little right leg, walk like a pirate, So if you get a really tough spring, no problem. That clutch will probably work pretty well, except when you got to release it with your left leg. Roberto, go ahead. You know about that, huh?
Oh, I was gonna ask, do those clutches wear out faster than regular ones?
It depends. So I'll give you like an overview. The stiff spring will not cause it to wear out faster. But a lot of times with the stiffer spring, and they're trying to make more power, they'll go with, maybe like a different type of lining, like maybe some carbon fiber or some different mix. That performance clutch may wear out faster, but the spring itself actually will not make it wear out faster. The best thing that you can do to make a clutch last longer is not slip it. So if you're coming to a stop, stab that clutch pedal quick, disengage it right away. And probably more critically, when you're taking off from a stop, the faster you let the clutch pedal out, the less you're slipping the clutch, the less it's wearing, right? So in a way, if this pressure plate spring is really strong and it causes you to like basically go from the clutches disengaged to bang, the clutches engaged, actually it would most likely prolong the life of the lining of the material. Right. So it's kind of similar to brakes, but brakes are a little unique in the sense where it's like if you really jam your brakes really hard, you're still having to do the same amount of work and slow it down. But it would actually be worse if you're constantly tapping your brakes, tap the brakes, right? If you let off the gas, just let it coast if you can. If you have to hit the brakes, no problem, but that is wearing your brakes down. It's kind of like the clutch. The more you can leave that pedal alone, the longer it's going to last. Now, that's just for wear, though. So let's break something else down. If you engage that clutch right away, that can be a little bit of like a shock to the system. So that can make all your driveline all of a sudden, like rather than a nice, smooth, cushy engagement, it's going to be like, bam, okay, we're engaged. That's going to be hard on some other stuff. The transmission, the transmission mounts, the drive shafts or CV axles, all that stuff is going to be kind of getting, I don't know if I would say like abused, but it's definitely going to be harder on it. So those clutches they may be more likely to cause driveline type of failure. And then like if we jump to this next screen, this is a factory clutch. If you look in there, we're going to come back to that, but there's springs in there. They make aftermarket clutches that have eliminated all those torsional springs, and it does make them feel a little more direct. There's not that little bit of play in the springs. It's not quite as mushy. But those springs are kind of like acting as a cushion for your driveline components, so some of those race clutches they're definitely a little harder on the car. Now, if you were to talk about harder on the driver, the spring in that pressure plate, if it's stiffer, it's going to be harder on the driver. It's just the way it's going to be. So there's other ways um, to increase the clutch holding force. So if you look right here, talks a lot about the diameter of the clutch. So like a bigger clutch disc with bigger surface areas with that could be good, but it could also go the other way. And I've actually got something I wanted to show you. So I'm going to pull this picture over. If you look, I picked a 6 puck, and actually we could go with that 4 right there. So if you guys see these, like a stage 3, or something like that, if I just pick this, it's going to be, it's probably the most extreme. If you look, your it looks like a brake pad, right? Your friction surface is right here. I don't actually want to buy anything. Don't spam me. Right here, you basically took your friction surface and you cut it in half. So in my mind, the first time I saw this, I was like, well, that's going to make it hold less torque. I don't have as much surface area, but I'm going to challenge you another way. If we still have the same friction surface or the same pressure plate surface, right? Because the pressure plate's still complete. So in that case, I'll jump back to that 6-puck if I can. This pressure plate is still going to be full size, but rather than pushing across a whole diameter, it's only going to push on those 4. Let's go with the 4 or the 6. It's only going to push on 4 specific points, which it's kind of like, it's almost like, this is a little bit weird, but you're going to understand it. If you took your entire body and you doubled it, and let's just say you laid your body or another person's body who happens to be exactly the same size as you, and you laid their body right on top of yours, all spread out, it doesn't feel that heavy. But if you were to tell that person, stand up and put all your body weight on one foot and then stand right on your chest, you know that's going to be pushing harder. It's kind of like that. So if we have, let's say, a 1,000 pounds of force generated by the spring, you're putting 1,000 pounds of force either A, on a whole entire disc, and it's going to be spreading that 1,000 pounds out across the whole entire disc, or it's going to be going to 6 points, or in the extreme case, we'll put it on just those 4. So these are going to be getting, it's 1,000 pounds per square inch. It's 1,000 pounds, but per square inch, that 1,000 pounds would be applied to less square inches. And so therefore it's more pounds per square inch. Mathematically is how you prove that, right? So if it was 1,000 across the whole disc, it's kind of spread out. If it's the 1,000 across 4 points, each one of these is now getting 250, whereas before maybe that was getting more like 125 type of math. All right, so these discs can actually handle more torque. But if you think about it, to me, to be honest, this is probably not the ideal case, because then we're putting all of our friction on just a few points on the flywheel, and that's going to be pretty rough on the flywheel friction surface and on the pressure plate friction surface. So these do tend to wear out faster. Yes, they'll handle more torque. So I'll give you a very specific example on one of these, but you have to promise to not make fun of me, because if you make fun of me, I'm gonna need to, like, I'm being bullied in the workplace, basically. I mean, I need to talk with somebody about it, tell them my feelings, tell them how people picked on me. I didn't feel accepted. So you guys remember that Civic I had? I know you do. I'm sure that you do. If you absolutely need me to, I will be. Unfortunately, I can remind you if I want. Let me pick one picture that will. I showed you my Civic, didn't I? I thought I did. Maybe I didn't. It's very relevant for this discussion, so I'm gonna actually go
The
ahead
blue
and
one?
yeah.
I remember that one.
Okay. So here, when I was living the life here, and I had these types of things. Oh, it's gonna pull it up on my other page, isn't it? Yep. Being a little funny to get on the same page. So this car, not my finest hour, but at least it was a manual. So you can just tell, I put a lot of time in this piece of junk, and it had a lot of cool parts in there. But the most relevant piece, and yes, some of those switches did things, but the most important piece was that. So this is a car that made 130 horsepower, and I added 150 more through nitrous. Oh no, it might have been 100. Whatever. I pretty close to doubled its horsepower just by spraying tons of nitrous and tons of fuel. All right, so when you look at that scuba tank right back there, the nitrous will come to this solenoid and the fuel will come to this solenoid. And then you got to size these jets appropriately. And it'll basically mix nitrous oxide and fuel, and nitrous NO2, N2O, whatever it is, has a lot of oxygen in it. So basically, rather than supercharging and putting this engine intake on there, I'm basically saying, you know what? I'll give you oxygen molecules. I'll give you them directly from this nitrous tank. Okay. So if I give a whole bunch of nitrous here and then I add a whole bunch of fuel, I've added a whole bunch of power, would you say? So when I did that, I can tell you exactly how the very first test drive went. I finished all the nitrous stuff at the dealership. I armed it. I filled the bottle. I took it out onto the road where we do our test drives, and it was kind of like now, like daylight savings just hit here, and so it was like maybe only like 6 o'clock or something. It was pitch black dark, couldn't see. Put it in first, punched it, and mostly what I'm doing is listening and like watching the RPM, watching the tack, and I can kind of see what's around me. But I had tinted windows, so mostly I could see the road in front of me, and it's a little hard to judge the speed of the road in front of me. So I just punched it, and then it slammed first gear. So I'm like, boom, red line shift, boom, and then next thing you know, second gear's like this, wham. I'm like, oh, man, this thing is really fast. I throw it into first, and then it slams, in third, and it slams third. And I'm like, oh, I'm at the top of third already. It's been like 2 seconds. That's like a 2 second 0 to 60. Thought it was amazing. Then I looked at my speedometer, and it was at 25. So I think it might have been under 25. I think it might have been more like 15 or 20. How am I at the top of third gear shifting into fourth, but only at like 20 miles an hour? There's a couple possibilities. One, I could be smoking the tires off the thing. That'd be cool. But there was no tire smoke. So then how the heck am I at the top of third and only doing 20? Come on, tell me. I think you know. What are we
Blue
talking about?
bottle.
I smoked the clutch. The clutch was like, oh, 130 horsepower. That's what it did yesterday. Today, give me like 250. And it was like, no, I'm done. That clutch never slipped one day. That clutch was fine. It probably was kind of old, but like it didn't slip at all. And then I put all that power to it, and boom, instantly when I realized that, I'm like, oh, let me let off. And then on the way back to the shop, in third gear, I'd throttle it and the RPMs would go up, but the car wouldn't move. That clutch was slipping. Like in one pull, that clutch went from everything's good to like, oh wow, I'm not sure I can make it back to the shop. I smoldered that clutch in like 2.5 seconds. Was done. So when you look at that, it's like, hey, I need to do a higher performance clutch. I need to do a higher performance clutch because the factory clutch can't hold the power from the nitrous. Makes sense? That's when you do a high performance clutch. If you don't have a real reason to do it, like if your car's pretty stock, I wouldn't. That 6 puck, 4 puck, whatever, that it just puts more wear on the flywheel. It just puts more wear on the pressure plate. The good thing is it didn't have really a stiffer spring. So as far as driving it, it felt like, not a real heavy clutch pedal. But if you were to put one with a stiffer spring in it, then you'd have a heavier clutch pedal, right? So I didn't really know a lot of that type of stuff, and that's why I'm trying to give you some extra material to comprehend. I just went with like whatever performance clutch that I could find. It was probably off eBay. It was probably pretty cheap. The good news was when I put the new clutch in, it did solve it. I could put all the power down now. The clutch wouldn't slip. The negative was it was like a 6 puck like this, but not a 4. And the negative was it was sort of like on or off. There was no like nice progressive engagement. So after that, driving it, when I would let it out and first take it off, it would constantly be like a little bit like especially taking off in first. So I sort of ruined the nice cushy drivability of the car. That 96 or 98 Civic was not actually a bad car to drive. It didn't have a ton of power, but if you needed to get on the freeway and merge, you could do it. You just have to run it up to red line, and that's fine. That's what that car is made for. I really ruined that car, to be honest with you. Trying to make it something it wasn't, and then it not being able to hold the power, and then having to put a clutch in so it would hold the power, but I had to eliminate half the friction surface area. So it just wasn't very progressive. It also, if you notice, this is a solid disc. It doesn't have those springs we talked about. From the factory, they're looking at all those type of refinements. When it's a race car, you're just looking to win, and that's cool. But like for the people who want that, that's like kind of like me. Like I promise you, I was in your shoes. You guys are going to try to make your car like a race car. And it's going to be cool. But the people who want that bad 6-puck feeling clutch and the noises and the squeaks and the whatever, those aren't really going to be your customers. That's what you do for fun, and that stuff is cool. But I'd encourage you to be able to do like more like factory type of repairs, because the people who have the money don't want to deal with the notchy, clunky first gear and the different type of stuff. If I want a race car, I'm gonna buy a race car from the factory that's been designed that way, and I'm gonna get all the refinements. And that's, I mean, if I didn't flake out on SEMA, I would be we could have jumped in the Camaro and driven to SEMA, no problem, no doubt, no questions asked, and done it all with 650 factory horsepower and a beautiful feeling clutch pedal with very smooth engagement. So kind of that's my lesson there. But that's why the aftermarket clutches can take more power. There's a couple different ways to do it. Cool. So now we continue after I've been so embarrassed because of that car. And yes, there's other things, but we're just gonna go. We don't ask anymore. Okay, so here we were talking about dry clutch, wet clutch. Okay, just keep those in mind. And then we talked about how we could increase the torque. And then just remember, when we're driving, when we go to shift gears, we need to disconnect, we need to reconnect. So the way that we're going to do that most simply is by depressing the clutch pedal, which disengages the clutch disc, and therefore your engine is now free to basically your engine is disconnected from your transmission, so you can go ahead and change gears. That's kind of what this one's showing. Here's your gears in your transmission. If you want to select a different gear, no problem, but you can't do it while torque is coming through the crankshaft. Make sense? I guess technically you could. Has anybody ever tried to shift without lifting? The no lift shift. Clutch pedal is up, clutch is engaged, and you're under throttle and you try to shift. Anybody done that? It can be done. It's absolutely brutal on the transmission. That's ridiculous. That's so hard on the transmission, it's hard to even explain. So you got a couple options. And the preferred from the manufacturers, push your clutch pedal down, that'll disconnect your engine, and then go ahead and change gears, no problem. The other thing that's been done, especially like in race car type of situations, you could actually kill engine power. So there's some things like some cars actually come factory with what they'll call like a no lift shift. So old school, you'd basically just keep your right foot on the gas pedal wide open, and then you just pretty much stab the clutch pedal, shift the gear, let the clutch pedal go. By the time you let the clutch pedal go, you're pretty much at red line, because you basically just rev bombed it. You push the clutch pedal down, and then you shift the next gear. You could do that, but they do have cars from the factory where the clutch pedal, you might have to engage it in a menu, but if you push the clutch pedal down, there's a clutch pedal switch, and that switch will give a signal to the engine control module, to the ECM, and it'll actually momentarily kill the spark or kill the fuel, probably the fuel. At which point your clutch is still engaged, but the engine power is off because they killed fuel injector, not fuel pump. Fuel pump would take a while to die. If you kill injectors, boom, that engine's not making power right then and there. They could even kill injector and fuel. Then at that point, you can actually do the shift. But what it'll do is it'll save you from having to completely disengage the clutch and completely re-engage the clutch. So you can actually put it in a no lift shift mode where all you got to do is like just tap the clutch pedal. Right. So you'd be wide open throttle, gas, and then you just tap the pedal and do a really fast beep, beep. So, and they do that from factory, believe it or not. But if they don't, they actually also sell a thing. They'll call it like a no lift shift box, or they have different terms. Okay. So the critical thing is we need to disconnect the engine power, or more precisely, we need to interrupt it. So for real, we're disconnecting it, but like technically you want to make it really fast. All you need to do is basically kill that engine power for a quick second, and then you could do it. Okay, from there, I want to explain why this is so relevant for you, not because of race car stuff. If you had a problem, just like this Jeep right here, this piece of junk, when I push the clutch pedal down, remember I already pre-told you, I think it's got air in the clutch line right now. When I push the pedal down, the clutch is still dragging a little bit. So when I go to shift, the shift is hard. Like going into first, it's almost like it takes a little extra effort. And when it goes in, you can feel it. It's sort of like still engaged. The clutch is definitely still dragging a bit. When I try to go into neutral, it's full on, like feels like it's blocked. The reason it's blocked is because the shafts in the transmission are still turning because the clutch isn't completely disengaging. Because I'm throwing the pedal all the way down, but it's not completely disengaging, right? So the test for that is very simple. Turn the engine off. If it shifts good in first, if it shifts good in reverse, easy, easy, easy. But then you start the engine and now it's harder to hit first and now it's harder to hit reverse. That's because that clutch is dragging. In other words, it's not disconnecting all the way. That's an ASE concept you have to know. But I want to break it down a little bit more. When we think about the clutch, remember, by default, the pressure plate is squeezing the clutch, so it's engaged. Only when we push the pedal down are we disengaging it, right? So as soon as you find a clutch is not disengaging all the way, it's generally going to be a problem with the release system. Does that make sense? The whole clutch master, slave cylinder, clutch line, fluid, air, all that type of stuff, that's all got to do with the clutch disengaging. So if we got a problem where the clutch isn't disengaging all the way, we need to be looking at the linkage, the pedal, the cable, whatever the system is. Cool. So this one's got a really good example. All right. And then we'll continue. So the main symptoms, the main components, I should say: flywheel, clutch disc, pressure plate, throwout bearing, pilot bearing. And then the flywheel's a part, but a little subpart. And you guys should know the pressure plate's going to bolt to the flywheel. So we're going to cover each and every one of those. And then most of them are going to use single plate. So let's take a look at what that is from a side view. So right here, we got the crankshaft in blue. You can see these bolts right here. These bolts bolt the flywheel to the actual crankshaft, right? So those bolts actually, they tend to be pretty high torque. They tend to be like pretty tight. On a Toyota, a lot of times you'll see those and they'll be 12-point bolts. Cool. So there's that issue. Now we can have some issues if we're doing clutch service. When we bolt the flywheel up to the crankshaft, a lot of times they'll say like make a mark and make sure you line it up with the mark in case there's run out in the crankshaft flange or whatever. So there's some basic procedures there. And then the clutch disc is in yellow here. But you'll notice the clutch disc isn't bolted to anything. The clutch disc is basically free to float in there, but it needs to be splined into the input shaft. So right here, the input shaft gets stabbed in there, and that's got to go ahead and spline with the clutch disc. That's the reason, as you'll see later, why we need to put that clutch alignment tool in. Technically, you could do this job without the clutch alignment tool, but if your clutch is not centered, if your clutch disc is not in the center, and you go to swing your transmission up here, the input shaft may not line up with the clutch disc hub. And the problem is, when I said it's floating, that's true when your clutch pedal's down. But when you're doing this job, you don't even have the linkage hooked up. So basically, the clutch disc is being squeezed really hard by the pressure plate up against the flywheel. You can't move it once you're ready to put the transmission in. So you got to center it first, and then you're going to actually torque that pressure plate. And then the input shaft of the transmission should go right straight in. You might have to turn a little bit, but it'll go right in there. So that's why we do the alignment tool. This is just a good view of that. And then, like I said, if the clutch disc is in there floating, except it's squeezed, but technically there's nothing holding it there, then we would put that clutch cover, and that's why they call it the cover. The clutch cover is the pressure plate in green right here. And that's got springs and depending on the type, it can have a few different types of things, but the important part is there's a spring, one type of spring or another, which is squeezing a friction surface like a rotor up against the disc. Okay. Then we're going to have a throwout or a release bearing. You call it the throwout bearing, you call it the release bearing. Which one you would call it, I don't know. It's up to you. So the purpose of the release bearing is basically to push on the springs for the pressure plate. And when we push on the spring this way, right, you guys can see to the left, when you push that spring to the left, that's going to actually pivot and release the disc up here. That part's a little bit weird. So pushing inward allows the outside to come outward. And that way the disc is not squeezed. Because remember, down here in the center, we don't have any friction material in the center. The friction material is out on the edge, right? So it's kind of weird. It's hard to show the pivot right here, but there's a pivot. So when you push this left, the top part goes right. That's how you release the disc. So anytime you're pushing on the pedal, like in this example, you see the pedal here. When you're pushing on the pedal, you're pushing on, like in this case, a cable, or it's really going to be pulling on the cable, or if it's a linkage, or if it's hydraulics, whatever it is, you're varying the force on this throwout bearing. The reason I want you to understand that is there's so many different types of clutch noises and failures. And a lot of times people just want to simplify it as, well, if the noise happens when the clutch pedal's up, it's the throwout bearing, but if it happens when it's down, it's the pilot bearing. And there's some logic there, but think of wheel bearing. And everybody should understand wheel bearing and suspension type of concepts before they're realistically going for a transmission ASE. I think that those would go in some sort of sequence. So if you've understood wheel bearings, how do you tell if it's a right or left wheel bearing? You guys remember? Like, if it's a right wheel bearing, how would I make right one make noise?
You'd kind of hear it when you're turning left.
Exactly. So when you think about it, you turn left, the body weight rolls to the right and it puts more weight on that right bearing. So when we're testing bearings, a lot of times what we're trying to do is change the amount of force that's on the bearing. Cool. So wheel bearings will sway different ways. As we get more into transmissions, we kind of check pinion bearings in a similar way. There's quite a number of bearings. Same with even with a connecting rod and engines. We'll kill spark to that cylinder and see if the knock changes, right? So we're usually trying to test a bearing by varying the amount of force. Exact same thing with this pedal. When we're just slightly pushing the pedal, releasing the pedal, we're just doing a little bit of this type of movement. If the pitch of that noise changes, we're talking about a release bearing, right? Just this little bit of movement right here will change the amount of force right here. That'd be like a release bearing. That's what I want you guys to remember. Not whether it's up or down, because it's not really accurate. Now, technically, if the clutch pedal's up, we're not putting any force on this, so there's some wisdom. See what I was saying? There's some truth to that. Whereas when you put the pedal down, you're putting force on it. But that's not how all the bearings fail. That's assuming like the rollers in the bearing are damaged or the race, right? Sometimes what we'll get is this bearing just gets like chock full of clutch dust. And, it may kind of like squeak. So if you're fully released, a lot of times this bearing may actually not make noise. And then when you slightly push the pedal, it might start to squeak. That's getting the bearing moving. Just slight movements of the pedal. All that's changing is the release bearing, is the throwout bearing. Okay, and then you could have it another way. We've seen quite a few of these bearings, they're made kind of loose. They sort of like rattle. You'll have the clutch pedal up, that bearing will just sit there and rattle. It'll sound horrible. And then if you push your clutch pedal a little, all of a sudden that rattle will kind of chill out a little bit. So just manipulating the force on that pedal, that's going to tell you a lot about if it's a release bearing type of noise. Now there's one more as we jump over to this side. We've pushed this clutch pedal down, which is essentially pulled on the cable, which pivots and pushes this release bearing inward. Now you can kind of see, right? We pushed the springs inward, which moved the friction surface outward. Now this disc is free to spin. This clutch is disconnected. Well, what's interesting is if you look right here, now with this disc disconnected, that's cool. That means this clutch will stop spinning. Okay, this whole assembly will stop spinning. The only reason this assembly spins is because the disc is pushed up against the flywheel right here. The flywheel spins the disc. And remember, the disc is locked in it's splined up in that input shaft. And so anytime the clutch is engaged, the input shaft is spinning. Whereas when you depress the pedal, it releases the clutch. Now the disc stops spinning. The engine, though, is still spinning. So now you have like let's say 1,000 RPMs on this blue flywheel, and you have 0 RPMs on this gray input shaft. Well, that's kind of interesting because look, your input shaft runs right into the back of the crankshaft. So that means your crankshaft is turning 1,000, but your input shaft is turning 0. That's why we have a pilot bearing right there. You don't want those two parts not having a good lubrication. You want a bearing in there. But when does that bearing work? That bearing really needs to work when your pedal's down. When your pedal's down, your clutch is disengaged, you got a big speed difference right here. So this is turning 1,000 and this is turning 0. Now you see why that bearing is so critical. Okay, we'll back up. Over here, your clutch is engaged. Your engine is turning and your input shaft is turning, and they're turning together. So who gives a crap about that bearing? They're turning together. You could have eliminated that bearing if you wanted. You could just, I mean, technically, if they're turning together, you could just weld your input shaft to your crankshaft and just never disconnect them again. So in the clutch applied, pedal up, position, the pilot bearing does nothing. The pilot bearing is really not even needed at that point. Okay, that's over here. When you push the pedal down, the engine continues to turn, the transmission input shaft stop. Now it's time for that pilot bearing to shine. So if there's something wrong with your pilot bearing, you all understand when you're going to hear it? So it's your pedal down. Your pedal down is going to initiate that big speed difference. Okay. Got to understand the mechanics of what spins and what doesn't spin. Now I'll throw one more bonus in there. I got a whole video on the different sounds described, by the way. So if you look in this one, your clutch is engaged, which means the disc is spinning with the flywheel, which means the input shaft is spinning with the disc because they're splined together. That means your input shaft is spinning. You know, we have a bearing right here. There's a bearing just barely inside the transmission, a lot of times called the input shaft bearing. That bearing would be spinning with the clutch engaged. So if you, let's say you hear a noise, you can hear that, right? But you vary your pressure on the pedal just a little and it makes no change. I'd be like, all right, I don't think it's a release bearing because it didn't really change sounds, just with a little movement. But then if you go ahead and you throw the pedal in all the way, now this one will stop. And if it's that bearing, the noise will stop, right? So a little, push down all the way, then it's quiet. I'd be thinking my transmission input shaft right there, my transmission input shaft bearing. Kind of makes sense. But if it was the pilot bearing, there'd be no noise. Then you'd throw the pedal all the way down, and then the noise would start if the pedal's all the way down. Then that'd be like a pilot bearing, because remember the speed difference? This sucker's turning and this sucker stopped. There's 3 noises right there. ASE will have a guarantee at least one of those, maybe 2, maybe all 3. All right. And we could diagnose those pretty like good enough where I wouldn't necessarily require a teardown. If I were to drive it and just be able to move the pedal and do some different things, I could tell you what bearing it was. The only one I may say to go further is if I diagnose it as a transmission input shaft bearing, I'm going to say, hey, it's the input shaft bearing, but you know, if that bearing's damaged, why is it damaged is a little sketchy. Did this transmission go low on fluid? Is it possible that there's other problems inside the transmission? So a lot of shops would say if it's a transmission input shaft bearing, you need to rebuild that manual transmission. All right, so there's some really good diagnosis you can do just from a road test. All right, and that's kind of what this is talking about. The whole purpose of that pedal and the linkage and all that crap is just to disconnect the clutch. It's a releasing mechanism, right? Releasing the clutch pedal applies the clamping force and reconnects the engine transmission. That's clutch apply. And then there could be different types. We could be talking about that regular clutch pedal, or we could be talking about the dual clutch. And the dual clutch, remember, is not so much an A3 concept, maybe just a bit. Okay, now what's the flywheel do? Smoothens the power pulses from the pistons during the power strokes. Remember, you got a 4-cylinder, you got 6, you got V8, you got whatever. There's going to be pulses, right? When cylinder 1 hits, pulse, then nothing. Then cylinder 2, pulse, then nothing. Then cylinder 3, pulse, then nothing. The firing order is probably not 1, 2, 3, 4, but it is on a couple of 4 cylinders. So bang, bang, bang. It's going to smooth those out because it has a bunch of weight. The flywheel's heavy on purpose. Do you want a lighter flywheel? Sure. You could put a lighter. I put a lightweight flywheel on that Civic, and it made it a little more harsh. Like, so when we talk a term NVH, noise, vibration, harshness, when you put a lightweight flywheel on there, it's not smoothing out the power pulses as well. It's going to make it not necessarily vibrate. It's not necessarily going to make it noisy, but it's going to make harshness. Like, you can just feel it. You feel connected to the engine more. You can feel the pulses. You can feel the road when you do those coilovers with all the polyurethane bushings, right? That's all harshness concerns. You're not isolated from the action so much. Cool. So lightweight flywheels are good if you want the car to rev up quicker, because it doesn't take as much time to get the mass moving. Lightweight flywheels are not good for harshness. Got to pick one. Pick one. Can't have both. Okay, and then it provides a friction surface for the clutch and also a mounting surface for the pressure plate. So that's where the bolt holes are. Makes sense? They should be heavy and can, in a way, store energy in the form of like inertia. So it took that kinetic energy, boom, and it went into the flywheel as inertia, which would mean, until we get the next burst of kinetic energy by cylinder number 2 firing, it's storing that energy as inertia. It's got some momentum, in other words, right? And then yes, they can, the heavy flywheel will kind of make it so your engine will be less likely to stop slow, like spinning. So a really good example of that would be actually dirt bikes, motorcycle stuff. So if somebody wants to go on these tight, small trails where you're like, having to bog out and go kind of slow, some people actually put heavier, they'll call them weighted flywheels. And that way the engine's less likely to stall when you're really low RPMs because it's got some more momentum. So we will manipulate flywheel weight to make it feel a little bit different. Then of course it's bolted to the back of the crankshaft. So like we looked at this picture, it was just a little more complicated. So here's your flywheel right there. Boom. There's your flywheel. So with it engaged and disengaged, the flywheel does the same job. Cool. And then here's one bolted that you can see is real. This one was just machined. See how it's like brand new looking, but over here it's a little rusty. This was a flywheel that was machined. So let's say you're going to do a clutch disc, you're going to do a whole like clutch service, you could get a new flywheel, or you could send that flywheel to the machine shop. And the machine shop will actually, they don't necessarily turn them on a lathe. We did turn one on the lathe once as an experiment, but they'll use a different type of flywheel surfacing machine. It's more similar to how they do like a cylinder head. It's kind of like a grinder cutter. So that one would be freshly redone. This is a simple flywheel because it's flat. A lot of times we have them stepped. So this one, for example, you can just kind of barely tell. This one is actually stepped. So this height is a little different than this height. Those are tougher to machine, and it brings in a whole new potential issue. If that one is machined wrong, you can get a clutch disc that won't disengage all the way, or you can get a clutch disc that will slip. Okay, so there's another picture, I believe that's in just maybe like a few slides where I can explain that. That's been an ASE concept before. A vehicle had a clutch performed and the flywheel machined, and since then the clutch slips, or since then the clutch won't disengage, right? That could be the machine shop's fault if it's a stepped type. So I'm going to come back to that. Then I want you to notice this flywheel has dowels. So the purpose of that dowel is to align the clutch cover, the pressure plate, if you will, perfectly, because we need the clutch disc and the clutch cover, pressure plate, to be dead center line with the crankshaft. All that stuff needs to be in place perfectly. So that's why we put the dowels. The bolts alone, there's a little bit of sloppiness in the bolts, so those won't align it. The bolts will clamp it, but the bolts won't necessarily line it. So that's why there's dowels. Cool. Oh, and by the way, there's also typically a dowel or some sort of like keyway or something down here where the flywheel bolts to the crankshaft. So a lot of times we're using dowels to center things. Flywheel to crankshaft, yes. Clutch cover to flywheel, yes. We're gonna center it. Cool. Overall, two types. Single one piece, so nice, so simple, so easy, so cheap. Dual mass, oh, a lot more money. There's a reason for the dual mass. It all has to do with that thing we talked about, NVH, noise, vibration, harshness. A little bit of vibration, but mostly more for harshness. Now we were talking about what the flywheel does, how it smooths out those power pulses. When you see this dual mass flywheel in I think about 2 slides, you'll be like, oh, that's going to make it feel so much smoother. It's going to be so nice and cushy on the driveline, and that's true. But it's going to cost 5 times the price. And generally, we can't resurface those. So if you're doing a clutch on a vehicle with a dual mass flywheel, you're probably replacing a dual mass flywheel. It's going to probably cost more than the clutch kit. So you can have it, but you can't have both. And then simple, inexpensive, reliable, all this positive on the one piece. Also on all these, it has a starter ring gear pressed onto the outer edge. Sometimes they're machined, sometimes they're welded. I did see at one point, it's actually a friend's, we'll call it an S10. I think it was a GMC Sonoma, but whatever, it's old school junk. And he had a clutch and it was slipping and he kept driving it was slipping, and then eventually he replaced the clutch. But after he replaced it, it was a no crank, no start. And it was like, well, that's weird. It could be so I'm asking guys at work, and they're saying like, oh, check the ground, check the starter cables, check to see if you connected the battery. And I was kind of like, no, because when he goes to crank it, you can hear the starter turning, but the engine doesn't turn. And they're like, oh, so it's a crank no start. And I said, not really. You can hear something, but the engine's not turning. You look at the belts and none of the belts are moving. And so it got really complicated. What it ended up being, he got it so hot with that slipping clutch, it actually allowed that ring gear to come free from the flywheel. So when you'd go to crank it, the starter would turn the ring gear, but the ring gear would just spin on a circle on the flywheel. It didn't turn all together. It was pretty nuts. So just remember, our flywheels will have a ring gear on the outside of them, and that's really just for the starter. Okay. So this one kind of shows the center well. That little dowel pin is mostly going to be for alignment. And also sometimes they're set up so that it's going to sit on the exact spot of the crankshaft, like a match mark, right? So if you've got one that has a dowel, you don't really need to match mark it because you can only put it on in one way anyway. Right, and then here's a stepped one. So the thing with stepped, let me jump forward right to here. Yeah, the thing with stepped that we're going to talk about is this height here on the outside is a little bit different than here where the friction surface is. Those are stepped. They're a little bit different. So if you look right here, we're using a caliper, and let's just say we measure the depth, and this is 30 thousandths of an inch. If it's 30 thousandths of an inch right there, that means your clutch cover, your pressure plate, is going to be bolted here, and that's going to leave 30 thousandths of clearance for your clutch disc to be a little loose. If you go ahead and you machine this flywheel, let's just say they cut this part another 10 and they left this alone, that would give you 40 thousandths clearance. Now your disc is going to be a little more sloppy in there. Right? That disc is not going to be squeezed as much. If that disc is not squeezed as much, what do you think the customer's concern is going to be? I'll give you 2 options. Slipping and dragging is mostly what we talk about. So it had 30 thousandths clearance, now it has 40. It's going to slip or drag.
Slip.
Exactly. It's going to slip because it's not being squeezed as much. You're exactly right. Now, let's say it went the other way. This had a 30,000 step right here. You send it to the machine shop and the machine shop's like, oh yeah, cut this down 10. And they cut it down 10 and then they go to break and they come back from lunch and they're like, oh yeah, now we got to machine the step. How much should they machine the step to keep it the same? The number. Cut the friction down 10. So if they're going to keep the 30 steps, shouldn't they cut the mounting surface down 10? But they forgot. So they cut it at 20. So if they cut this one down 10, if they cut the friction surface on the step down 10, but they cut this 20, it's no longer a 30,000 step. It's only a 20, isn't it? So now it's going to be a little tighter on that disc. What's that symptom going to be? Come on now, give it to me. One was slipping, so this one by default would probably be
Dragging.
yeah. All right. So what I mean by dragging, you push the pedal down, that should give your disc enough room to be totally loose, and it should stop your transmission from turning. Cool. But instead, now we only have 20 thousandths clearance because they messed up and they over machined the step and under machined the friction. Now you push the pedal down and the clutch disc is like, yeah, I'm kind of freed up, but like I'm still sort of dragging across the surface, which means the disc doesn't stop. The disc continues to try to follow the flywheel at least a little. That's going to turn your input shaft a little. When your clutch is down, but your input shaft is turning, do you see how that would kind of like try to make the car go? It's going to be kind of like starting to stall out maybe. If you're at the intersection and you put it in first and you have your clutch pedal down and it's still trying to engage, it's going to drag you into the intersection. Make sense? That's exactly what I got with this Jeep, except I know it's not a machine flywheel because I didn't machine the flywheel, right? So the symptom of an improperly machined flywheel because they messed the step up, if they over machine the step, if they over machine the mounting surface, but they under machine the friction surface, it'll give you the exact same symptom as air in the release line, in the clutch cylinder line. It's kind of crazy, but that's why you have to understand both. So if you think about what I was saying with this, when I push the clutch pedal down, it's kind of like hard to get it in first and it's hard to get it in reverse because it's still engaged because of the air in the line. It do the exact same thing if you mismachine this clutch with mismachine this flywheel. But remember, they could mismachine the flywheel the other way. So if they over machine, like we talked about first, if they over machine the friction surface, but they under machine the step, that would mean it's going to actually slip. Generally speaking, clutch release systems don't make them slip. Makes sense? Because if you bolt the clutch up, it's engaged. The purpose of the release system is to release the clutch. So how the heck is the release system going to make it slip? You'd say it can't, right? There's one exception. I'm gonna come back to that. So if they mismachine the flywheel the other way, it may slip. But other things that could make that clutch disc slip is the clutch disc is just worn out. Maybe the spring clamping the disc, the spring, which is part of the pressure plate, clamping the disc is weak, and that's going to make it slip. Maybe you have a massive rear main seal leak, and that's running oil down on this flywheel, and that's going to make it slip, right? So there's a bunch of stuff that'll make this piece of junk slip. Maybe you have a very glazed, super shiny friction surface here on the flywheel and on the pressure plate. That would also make it slip, right? But let's go back to the release system. The release system having air will not make it slip. The release system having a master cylinder, a slave cylinder, a line leak, a hose leak, none of that's going to make it slip. No. But if your adjustment is off and you release the pedal, but it's actually still disengaging the clutch partially because your adjustment's all jacked up, that could make it slip. And that's the only exception. If your adjustment is off where it's still releasing the pedal partially, even though your pedal's all the way up, okay? Log that in your mind because we're going to come back to that. Cool, so there's a lot of good info on flywheel. This one, as you can see, is a little rough, but this is a dual mass. This has hot spots on it, by the way. So this, as soon as a flywheel gets those hot spots, it's junk. It's just like a rotor. the hot spots harden the metal right there. So if you were to try to machine this, the cutter would actually cut the softer, nicer metal right here deeper, and then these spots would end up raised up because the bit will just glide across those. It'll be like, I can't cut that. That's hardened. Makes sense. So you'll make it even worse by trying to cut this. Other thing here is it's a dual mass, so you actually can't really cut it anyway because they move a little bit independently. So I wanna have you remember what this looks like. See how it's bigger, it's thicker, it looks a lot more complex. It is. So the reason why in the center we have kind of like a blue disc, and that bolts directly to the flywheel. And then we have springs, dampers, sometimes little rubber bumpers, all sorts of little funky little mechanisms. And sometimes they even use almost like a planetary looking little pinion gears and stuff in there. And that'll make it so your friction surface can actually bounce up against these springs, turn these little gears a little bit, right? Bounce, 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 bounce. But your center part is bolted solidly to the crankshaft. Right. So there's moving parts in this. That's why you can't really machine this because the whole thing bounces all over. They'll sometimes call this like torsional damper. The reason they call it a torsional damper is because remember, your engine, which is in the center, your crankshaft's right here, it's getting those power pulses. Cylinder 1, 2, 3, 4, boom, 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 boom. Those pulses could actually, make this thing go fast, slow, fast, slow, fast, slow. The pulses are going to be punching the inside of this thing. If those pulses are transferred to the spring and the little cushion, the rubber bumper, it's going to smooth it out, and your actual clutch plate, your pressure plate, is really only going to touch the friction surface, which has already been pre-smoothed out. Makes sense? So the dual mass flywheel makes the clutch get a really nice, smooth, not power pulse, not harsh, clean feel, and that does make the car feel more smooth. Okay, so we're basically absorbing a bunch of those engine power pulses in the dual mass flywheel. And that's why a lot of times they'll call this the ultimate engine dampener. You could have a harmonic balancer, right? And that thing's kind of heavy, and that makes it so it sort of absorbs the power pulses. But if you notice, a lot of the newer stuff, they have smaller and smaller and smaller crankshaft pulleys. Not necessarily smaller like this, but like you look at it, it's really just a pulley. Whereas the old days, it was like a pulley with a big weight and some rubber and like some stuff. That was to absorb the power pulses. Now it's more of a basic, simple crank pulley. And that's because most cars are automatic. And remember, we have a big torque converter with a bunch of mass and the fluid. That's going to isolate a lot of those power pulses. But if it's a manual, they've been going more and more to the dual mass flywheel. That way they can keep that standard basic crankshaft pulley. And they can get a lot of the smoothness similar to a torque converter because they got this dual mass flywheel. That's the positives. Like I said, the negatives, well, when you're going to do a clutch, and especially with this one, it's all hot spotted. You need a dual mass flywheel. That could be $800. So great feel, great for the driver. Everybody loves it, but a little expensive. And you as the technician need to know, if there's damage to that friction surface, you need to change it. Especially those hot spots, that'll kill it. Even if it drives the price up, you could say, hey, we can try to reuse this, but remember I was saying it's kind of like pad slapping. It's like, hey, we can slap these pads on here, but if you have another issue, we got to redo the job. Except this time you got to pull the transmission to redo the job. See, so that's why I wouldn't really give them the option. I would look it up on service info. If it has a dual mass flywheel, I build it into the price of the job and tell them, hey, if I get in there and the flywheel's good, and it probably won't be, then I'll save you the money. Okay, then I won't put it on, but it's probably going to be messed up by the time you're doing a clutch. Makes sense? And so anyway, that's kind of like what they go on, especially with diesels, high performance, but luxury cars. So that sounds weird, but I'll give you what I mean by that. If you were going to have a manual transmission, let's say, we'll give Nate a little love here. A GR Corolla, I actually don't know if it has a dual mass flywheel, but I'm gonna say it doesn't, okay? But I'm not telling you as a matter of fact. A GR Corolla is really more of a race car. It's not a luxury race car. Makes sense? So they may very well not put a dual mass flywheel in the GR Corolla. You're expecting to feel harshness. You're low to the ground, you're bang, bang, there's noises, there's an experience there. However, if it's a Lexus RCF, that's like a performance car, but it's kind of a luxury car. See what I'm saying? So on a RCF, you're going to see a dual mass flywheel if it happens to have a manual. Same with um, on a Cadillac, right? If it's a CT4 or CT5V Blackwing and it's a manual, it's gonna have a dual mass flywheel. They want it to be smooth. They want it to be like a race car, but they want it to be like a race car where you're kind of like isolated from the vibration and the harshness. Makes sense? So they love these dual mass flywheels on those types of vehicles. And the customers who are going to buy that high performance and luxury vehicle, well, they need to be able to spend the money on a dual mass flywheel when the clutch disc is shot. Makes sense? Now, we talked a lot about the cover, aka the pressure plate, and here it is. So I'm going to use these terms interchangeably because I want you to be able to use them interchangeably because the ASE is going to use them interchangeably and people in general are going to use them interchangeably. I would say mostly we're going to be calling it a pressure plate in ASE land and with general conversation, but with Toyota, they're always calling it the clutch cover. Just different. Right, so look at some of the parts. The diaphragm spring is arguably the most important part, at least one of them. So the diaphragm spring, that's what's pressing your clutch pedal. That's what's pressing your clutch disc in. Like if you look at my elbows, it's like this. They're trying to be in this shape. My elbows are going to push the disc into the flywheel. Make sense? And then they're going to pivot here. So if we push in the center where my fingers are, that's actually going to kind of reverse the motion and let that disc go. Okay. So when you're pushing down on your pedal and you feel it stiff and you feel the pedal return back, that's because these springs, you're pushing on the pedal, you're deforming the diaphragm spring. And they're like, yeah, I don't want to be in this shape. So as soon as you start to let up your pressure, they're going to push your foot back. The clutch release system doesn't generally have a lot of spring, like return spring. Like sometimes they'll put a little return spring in the master cylinder, but a lot of times they don't put anything in there because they shouldn't need to. So it's kind of interesting. If you have a lot of air in the system, you'll push your clutch pedal down and it'll just get stuck there. And you'll be like, hey, come back. The reason it's not pushing back up is because you pushed it down and that compressed the air and it never really pressed on these diaphragm springs. So there's no spring trying to push the fluid back, which is trying to push your pedal back. It's all just been absorbed by the air and it'll just get stuck. So you ever jump in a car and push it to the floor and the clutch pedal stays to the floor? You got an issue there. There's at least air in the system, if not like a totally destroyed clutch master piston seal, right? So that type of thing. And then from there, this is where it'll pivot a lot of times. There's also going to be some internal stuff where this pivot ring is going to press on the actual pressure plate. The real pressure plate is the metal part like a rotor where it's going to actually contact the disc. So part of the reason that Toyota likes to call it the clutch cover is, look, the pressure plate's here. So what is all this together? All this together is the clutch cover. And it includes the pressure plate. And we're very concerned about replacing the pressure plate when we do a clutch because the pressure plate has taken a lot of the wear, right? The pressure plate is one of the two rotor parts of the system, but like technically we're replacing more than just the pressure plate here. We're replacing the studs, we're replacing the diaphragm spring, we're replacing the pivot ring, the retracting spring, the straps, there's rivets, right? We're going to be replacing a few parts. And then you can see these straps. A lot of times that's really for torsional strength, quite a few little details on there. So these are all the parts that are in there. Makes sense. And generally, if we're worried about this, it's either damaged pressure plate friction surface, probably most common, or one of the most important is an issue with the diaphragm springs. So by the time you go to do a clutch, that spring has been flexed hundreds of thousands of times. So we'd expect the spring to have some problems. And also the pressure plate friction surface is going to have some problems. And that's why we do that as part of the clutch kit. Okay, and so we talked quite a bit about dampers already. And then again, it provides the clamping force. The springs can vary. Okay, so I want to show you the springs. All this is basically describing what it does. That's kind of what I described with my arms. But the spring type can vary. So like the diaphragm was pretty common. That's the one that we saw. And by the way, if you don't know what type of clutch cover spring it has, it's not a real big deal. Just want you to be able to know that they do vary. So like there's a really good one of the diaphragm springs. Sometimes I've even called these the finger springs or something. But right here is where that release bearing sits. Remember, if we want to release those, that's my fingers. If we want to release my elbows, I need to push those down so my elbows will come up, right? So we're going to actually push right in the center of that. But as you can see, we need something that's going to sit on all of those diaphragm springs. And that's really why we have the release bearing. And the release bearing is going to be pushed by the fork. So the fork sits on the bearing, and the bearing is going to actually sit right on those finger springs. And that's why when we vary the pressure, it'll actually change the force on that bearing. Because really that bearing is just trying to like lightly sit there, maybe touch it, maybe kind of touch it, but not really push on it hard. When you push on it hard, the bearing's like, okay, now I got to do some work. Because the outside of the bearing is going to be engaged with the fork, but the inside of the bearing is on a race that is actually coming into contact with those springs. So some people have made the error of thinking, when you push the pedal down, it's basically bringing that bearing was not even touching, and you're basically bringing that bearing into contact. And when you hear the noise, it's because that bearing is ripping across these springs and banging them up and ripping. It doesn't really work like that. That bearing is going to be pretty much touching those springs. It might not be touching them with a lot of force. There could be a little bit of room for movement, especially if that bearing has a little rattly motion and you lightly add pressure. Now it's sort of like holds the bearing a little more firmly together. But that bearing is going to be more or less in contact with those springs, even with your pedal up. Okay, and then there's a coil spring type. Like this, they'll actually put little coil springs in there. So this may help you understand it a bit better. But when we press the bearing into these release levers, the release lever is going to go down and it's going to pivot and pull this back upward, like kind of in towards the transmission side, but it's going to go up against those coil springs. So it works really the same. Who cares whether it's one type or another type? If these springs are worn though, you can see it's not going to clamp that clutch disc as hard. It's kind of like worn coil springs in a car. If the coil springs are worn, it starts to sag. It's not really lifting the body off the suspension as much. Kind of makes sense. Similar concept. And then there could be some varying types, like this one's a centrifugal or a semi-centrifugal type. So as this one spins, it's gonna utilize these weights, and the faster it spins, the more these weights will generate centrifugal force, which will actually assist the spring. So if this one primarily uses a diaphragm spring, as it gets spinning, these weights are going to add more force to the diaphragm spring. And that would be a great design if you needed more clamping force. Like let's say, we'll pick on, I don't know for sure that this is the case. In fact, is the Honda Civic Type R automatic only, or does it come in a manual? I think it might be auto only, huh? Or like some sort of manual shifted automatic. Anybody know? Roberto, you're the Honda guy. What you know about that car? All right. Let's make it a different one then. So let's say it's any one of these performance cars from the factory. If they let's say that you buy the regular Civic or the regular Corolla, you know, they don't make a ton of power. Then you buy the Type R or the GR. They obviously make a lot more power. You'll need to probably increase your clamping force to have that clutch not slip like my Civic, right? I put the horsepower to it and the clutch was like, I'm out. In Gen Z speak, the clutch left the chat. Okay. The clutch was cooked, these types of things. So I need to make a modification and I went with the 6-puck. You could have gone with something like this. This looks a lot more expensive though. And so this is kind of what I'm saying. From the factory, they may be like, oh yeah, let's do a semi-centrifugal pressure plate. And that way, when we get up to higher speeds, it's going to squeeze a lot tighter. But the positive of this, look, clutch pedal effort is not increased at all. So this is still going to have a nice soft clutch pedal. Everything's going to feel normal. It's not eliminating the damper springs. It's not making it so you only have 6 points of contact. So it's not going to be like a on or off. This is going to be a nice clutch. How they do it? By using these weights. You know, so if it were me and I was the manufacturer, I'd do it like this because I don't want somebody jumping in and be like, man, this car just feels harsh. You know, see what I'm saying? And now we're onto the disc. So the disc varies as well. Sometimes we'll call it a driven center plate or whatever, but mostly what we want to do is focus on friction facings. So those are the friction material, the linings. They can be riveted mostly. There's a wave spring that I'm going to show you. The central hub is some sort of strong, it might be an alloy or some sort of steel, which is splined. And I want to show you that broken down because this part's really critical. And then the drive can be transmitted in different ways, especially when we have these torsional vibrations we're worried about. We need to dampen those. How we do that? Well, I'll show you. All right, if we were to start right with the center, this hub would be splined to the input shaft. Make sense? So basically what drives the transmission is this hub. But we're going to also put the hub plate right here is going to go into the hub. The torsional springs are going to sit in the hub. So if you notice right here, these are loosely connected. So that means like this central plate doesn't bolt directly to this hub. We're going to swing it in here. The springs are actually what's going to contact that hub, and then we're going to bolt it up like a cover. But technically, these are loosely fit together. They're not bolted solid. Now we're going to take the friction linings and attach those to the central plate. And then a lot of times they'll call this the wave spring. So these might have a little bit of a wave to them so that there's a little cushion right there. So if you measure a clutch disc, first off, a lot of times what we'll be measuring, by the way, is we'll almost be measuring tread depth right here. We'll use the grooves per se, and we'll use like a little tread depth gauge like for a tire. But there's another way to measure it. You can actually measure the clutch disc thickness. To measure the clutch disc thickness, you have to actually squeeze the clutch first because these wave springs try to spread it out a little bit. If you ever look at a clutch disc, it's kind of like you can squeeze it. There's a little cushion right there. Cool. So that's part of the purpose of the wave springs. When we put these friction facings on, I want to basically walk you through the power flow here. The flywheel spinning right here. When we engage the clutch, the friction facing is going to engage that flywheel and it's going to make it spin. That is riveted to the wave spring in the central plate. So that is going to get the pulses, right? So under 1, 2, 3, 4, 1, 2, 3, 4, it's kind of rough. Each one of those pulses are going to actually take this central plate, try to push the hub, but it's got to push the spring into the hub. And that's why the hub is going to basically be smoothed out because we're hitting those torsional twisting forces up against the spring. And the spring's going to absorb some of it at least. I don't know how much, some of it. And then the hub is going to turn a lot more smooth, a lot more dampened. And so what's going through the transmission is basically smoothed out power. That's why we have these springs. That's how this setup really works. Okay. And then, you know, this can vary. So if you wanted a race car one, we're just going to attach this central plate right to the hub directly. And we're going to be like, springs, forget it. We don't need you because we're not worried about NVH. We're worried about, you know, lightweight and performance. Now I want to explain something. If one of these springs was broken, and it was trying to hit, and that spring was loose in there, it can actually make a knock. It'll be like knocking, clattering, crack, 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 crack. That spring will actually make it sound like it's got an engine knock. But what's interesting, if you push the pedal down, that's going to disengage the clutch disc, and this disc will stop. So it'd be like, oh, I got a rod knock. But when I put the clutch pedal down, it no longer rod knocks. That ain't a rod knock then. Make sense? That would actually be probably, it'd be very similar to a cracked flex plate. It would change with, park or drive, but in a manual, that's going to really change with clutch pedal engaged, clutch pedal depressed, which is disengaged, clutch pedal up, which is going to be engaged, right? That would change a lot. That could be a damaged torsional spring. Right, that's ASE concept. We talked about the flywheel, I think, enough. This one shows a pretty good view of a different type of torsion damper. I wasn't entirely sure if these are springs, but they could also be like some sort of rubber block, some sort of different type of dampener. Is pretty interesting. But you can see the hard picture of the actual parts. The friction lining being riveted. This is riveting this side. This is a rivet coming through the back side, because remember, we got friction material on both sides. If you wear this down to where it's totally worn out, you'll contact the rivets. When the rivets contact the flywheel, that flywheel gets shredded. That's like basically going metal to metal. Okay, so it doesn't necessarily pay to run this thing till it won't move anymore. It's kind of like when the clutch is slipping, and this is going to go through some of the steps to check. It's really time to go in and fix it. Do the clutch, do the, probably still going to be a clutch kit, but maybe you can save the flywheel type of thing. All right, so that was a good one. This is what I was saying about the wave spring. See, there's a little bit of a wave to it. So if you had to measure the clutch thickness, you'd actually need to squeeze this together to measure it first. That's why most of the time they're having you measure the tread depth, if you will. All right, and then you can see this gives it like more of a progressive feel. Allows progressive application. Again, noise, vibration, harshness. Truth be told, though, if a customer is worried about noise, vibration, harshness, you know what they really need to buy? They need to get automatic. To be honest, a manual is always going to be, to some extent, more crude, more notchy. You're going to feel something, but in those performance luxury market, the RCF, the older one, or the Cadillacs and even the Beamers in a lot of ways too. Customers want them to feel smooth, but they all also want them to be sporty. So we've been trying really hard to make them both, and we've gotten decent at it actually. Now let's talk about how it's going to release. Here is the throwout bearing we've talked about so much. This is what's going to engage the springs. Cool. So this is loosely sitting up against the springs. When we push the clutch pedal, some sort of mechanism, mostly going to be hydraulic, is going to push on this fork, or if it's a cable, it's actually going to pull on the fork. That's going to pivot, and that's going to send this into those springs as we're pushing down on the pedal, right? That's why when we vary the pedal pressure, if it's a bad throwout bearing, that's going to vary the throwout bearing noise. Make sense? So not super complex. And this throwout bearing a lot of times is just held to the fork by like some sort of little spring. A good clutch kit will come with a spring replacement. No clutch kits come with the fork. You shouldn't really need the fork. You should be able to clean the fork up, lube the fork in multiple points, replace the bearing, and replace the spring, because the spring can actually break or become messed up. The spring doesn't do a lot of work other than really just hold it there. Cool. And there's a lot of different types. There could be like a whole bunch of different types of bearing. Maybe the thrust type angular contact ball bearings or similar. They can make different variations. Here's that clutch release bearing. So first off, terminology. Throwout bearing, release bearing, same thing. Toyota likes to call it the release bearing, and I tend to like to as well, because you remember it releases the clutch. The throwout bearing is like it throws the clutch out, which is another way to say release. So interchangeable terminology. You may see one way or the other way. So you got to be bilingual here. Release bearing, throw out bearing. Cool. So you can see that release bearing is going to be thrown by the fork against those springs. It's going to push those springs in, which is going to allow the outside true pressure plate friction surface to release the disc. Makes sense? So that's the actual motion right there. There's some really good 3D animations, which we learned from the last one. I cannot show you an animation during this video or it'll totally be furious with me with copyright claims. So I've got another clutch operation video that's basically linking you to someone else's. The 3D animations are amazing. They're not always perfect, but seeing the motion in an animation, way better than I can do with reading to you. Okay. So consider all these things, right? Remember that release bearing where it is. Remember, it could be called the throwout bearing. Remember, the fork pushes up against it. And when you push the pedal, your clutch master pushes fluid and your fluid pushes the clutch slave cylinder, and the clutch slave cylinder pivots right here. That's what that little round thing is. That needs to be greased when we do the job. Otherwise, it'll go. So if you ever have a car and it goes with the pedal, it may not need a clutch. It may really just need that to be greased. But in some of them, it's external. And so you could grease it, no big deal. In other ones, they can be internal. So you're going to have to pull the transmission. So that's why it's critical when we do the clutch job, make sure you're cleaning all the clutch dust and you're greasing all the right points with the right type of grease, which is a high temperature. It's really darn similar to like disc brake lube. Okay. So we'll come back a little bit on the service because we got a photo sequence of how to do the work. Okay. And then this is a different type of bearing. They do tend to vary, but these bearings really need to be centered. A lot of times they're self-centering. So that's a pretty cool option. Right here, you can see the inner race of this bearing is in green, and that is riding on, a lot of times they'll call this like the clutch hub right here. That clutch hub is not part of the kit. That clutch hub is bolted to the transmission. So when we're doing the clutch service, if we had a release bearing that went, it got procrastinated, and there was a noise, and there was a noise, and there was a noise, it can actually seize, and then that inner race right there in green will spin around on this hub and it'll damage the hub. If the hub is damaged, it needs to be fixed. If the hub is a little messed up and we can clean it up really good with maybe like some fine sandpaper or the little whiz wheel or something, good, no problem. But if it's actually grooved or something, gotta fix it. You can buy that. You can get those separate from the transmission, right? But so you can see the inner race slides across the clutch hub. The inner race has the ball bearing, and the ball bearing is going to be basically having its own race, which pushes on the diaphragm spring. So that's how they're connected. So let's just say it's clutch pedal released. This is not going to have a lot of force on it. It may just be like lightly sitting there. And that's why the diaphragm springs, those are part of the clutch cover. So those suckers are spinning, which means this race is going to spin with them, which means that bearing is probably going to maybe spin. And then in this, the green part, that's actually going to be still. The inner race is going to be still. So with no pedal pressure, this might spin. It might spin a little. It's not going to really be carrying a lot of force though. Muting you, Jimmy. Okay. Now let's talk about what happens when you press the pedal down. All of a sudden, when you press the pedal down, your fork is going to basically throw this or move this. And when it does, the diaphragm spring, the inner race, the ball bearing, the outer race, those are all going to be squeezed together. And so that's when we have to have that ball bearing able to really roll freely, right? This bearing should be it should be clean, but it should also have grease. It should be in good condition, and the bearing will make no noise. But let's just say you had a defective release bearing. Well, that would mean these ball bearings are kind of messed up, and they wouldn't make a whole lot of noise probably, while your pedal's up. But then once you start to put pressure on the pedal, this ball bearing's like, oh, I have to roll. Well, I don't want to because I'm all pitted or I'm got flat spots, these types of things. So it's going to start to grumble and rumble and growl and make noise. And the more pressure you put on it, the more it's going to grumble and rumble and growl. Because you can see this bearing is what allows this to stay still while this spins. And then, of course, when you actually, have them engaged, they should both be spinning. But when they're disengaged, one's going to spin, one's not going to spin. So it's all changing the load on that bearing. That's how we diagnose it. Okay, and then this one's old school. So this one's a pull type. Pull type would be more common with a cable. And then we talk a little bit about the clutch fork. Clutch fork's usually steel. It's going to be pretty strong. It's not something that should need to be replaced, but the clips usually will. So we replace the clips because that holds the bearing in place. Makes sense? This is a different style. So this one eliminates the fork. This one, if you look, we have master cylinder, clutch master cylinder pressure is going to come in with brake fluid. This becomes the slave cylinder, which will come into the hydraulic components, but it's also functions as the fork. So if we pump this up with pressure, it's going to basically expand, and this is the throwout bearing right here, and it's going to go right into that diaphragm spring. Sometimes they'll call this like a concentric or a collar style. These are better and worse depending. Overall, they're self-centering very well. They don't have a fork. There's nothing to lubricate. All the action happens in one piece. The negative is if the slave cylinder leaks, you can't replace just the slave cylinder. This is an assembly. So slave cylinder, spring, it's kind of like almost what would be the fork, release bearing, all is one piece. It might be several $100 and you got to pull the transmission to replace it. But it's a good design. This line over here looks like some sort of return line. It's not. That's just the bleeder, which is one of the reasons I'm not a huge fan of these. When you go to bleed these, it's sort of like let's just say you get air and the air's up here. You need to get the air down here and out the bleeder, and they could be a little bit of a hassle. This one actually may very well be upside down. The bleeder's usually higher, but they can be a little tricky to get the air out of sometimes. So can the old school slave cylinders, but if it's an external slave cylinder and it's fighting me, I can always unbolt it and like move it around to try to get the air freed up to come out the bleeder. Sometimes they actually have SSTs that are used, special service tools that are used to perform the bleeding. So this Jeep I know is gonna be a pain in my butt because it's got this concentric style. It's gonna be a hassle. I already know it. And then the pilot bearing we've talked about a little bit. So your pilot bearing, this is a true pilot bearing. It's actually got an outer race, rollers, and an inner race. That's why it's a pilot bearing. That is pressed directly into the crankshaft. Sometimes they're pressed into the flywheel, but most of the time it's the crankshaft, right? Because this is bolted up to the crankshaft, so it all depends on what the outer race is being pressed into. This one actually might be the flex plate or the flywheel, but most of the time, especially with the pilot bushing, this is just like a brass slug that gets pressed right into the crankshaft, and the whole purpose is to support that input shaft. So if we jump right to here, it's a little hard to say. If it's in the flywheel, it's because this flywheel's got a pretty big center hub right here, which is going to be bolted to the crankshaft, or the crankshaft is coming through and we're pressing it right into there. Either way, the negative is it's a blind hole, which means there's no way to get to the backside of it to drive this pilot bearing out. So if you need to change one of these, it's very helpful if you have a special tool that's going to pull the bearing out, but sometimes you'll try to pull the bearing, it'll rip the inner race out, it'll pull the rollers will fly out, the outer race will be stuck. They can be a hassle. We're gonna make this universal to all cultures and say, if you were the backyard mechanic, right? If you were like the hillbilly, which is not necessarily indicating one person's race or color, if you were the goat roper, if you will, if you were the backyard mechanic and you didn't have the special tool, you could pack a bunch of grease in there. It sounds crazy. You could pack a bunch of grease in there, and then if you had something like this input shaft and you put the input shaft in the center, you'd try to drive the input shaft in. It won't go in because the grease will function as like a liquid and it'll be basically like hydraulically locked, right? So the more you push in, you'll increase the pressure on the grease and the grease will try to push out. And if you do it right and you smack that input shaft with a hammer, like if you make a little special service tool, you can actually hit inward, which will pressurize the grease and pop the bearing outward. Okay, that's one way to remove these, and it does work. We've done a couple videos on that. If you were a different type of backyard mechanic and you were trying to use bread, let's say, for example, bimbo bread, perhaps, okay, bimbo white bread maybe, and you stuffed a bunch of bread in there and you did the same thing, that bread will actually kind of function the same as the grease, and you'll hit the bread in and the bread will kind of mush out, like it'll go back to sort of like when it's doughy, and it'll actually drive the bearing out. So if someone says, oh, I get my pilot bearings out using bread, it's funny, it's kind of a joke, but they might actually do that. Would I do it that way? Probably not. I'd rather, I have grease right there at the shop. I don't necessarily have bimbo bread or any other type of bread for that matter. And if I did have the bread, I'd probably want to eat it rather than waste it on removing this bearing when I got a bunch of grease, okay? Now you got a good lesson. And then like we were saying, this is not a pilot bearing. This is a pilot bushing. So a lot of times we'll say pilot bearing. It may very well just be a bushing. You'll notice simple slug of bronze, brass, some soft metal does the same thing. The outside of this, the OD driven into the crankshaft, the ID should be perfectly sized for that input shaft to ride on, right? It's not going to be press fit. The input shaft's just going to be like, oh, okay, this is nice. This metal's soft. I'm good. That way, when you push your clutch pedal down and your engine spins, including your crankshaft, the bearing, the bushing spins, but your input shaft stops. And so therefore the actual bearing, the bushing going around your input shaft is not going to wear it out. It's not going to gall it, right? We'd rather have all the wear go into that bushing than go into your input shaft, your transmission, and have to replace your transmission. That's the real purpose there. So we could use simple bushing. Those would need to be greased, by the way. That's part of the job. But personally, I think the bearing's a little bit of a better option, as long as the bearing's well made, because you actually have rollers. The bearing basically should be able to withstand more forces and not wear, right? There should be almost no friction here, whereas this is inevitably going to have some friction. Cool. So you have different types of pilot bearings there. And then the one thing you can see, this is a little dangle arm, a little dingle dongler of your input shaft. So your input shaft has a friction, has a surface machined to go right in that pilot bearing or right in that pilot bushing, and that's going to provide a lot of support. So your transmission input shaft's kind of long. It's got to go all the way through the bell housing. The clutch disc is on there and everything. So there's a chance it could have some flex. But when we land the end of that input shaft right into a pilot bearing or bushing, now everything is chilling. It sits nice. On transaxles, though, we may not have that. And the reason why, this transaxle, this whole input shaft, has a big support at the rear and it has a big support at the front, which means like this is already pretty well supported. So you may see a lot of transaxles don't even use a pilot bearing. It's already supported enough. Makes sense? So if you work on a front wheel drive and you're like, hey, there's no pilot bearing, well, we could do that. But rear wheel drives will, and some front wheel drive transaxles will. It can tend to vary. All right, now talking about the clutch operation. Remember, the clutch by default is applied. When we work the pedal, when we use these systems, that's to release it. It could be cable, mechanical linkage, or hydraulic. On newer systems, but not true manuals, it could be electric motors. So that would be more like a dual clutch. That Hyundai, we have the school, a couple of you guys helped pull the engine out. We did the diagnosis on the knocking. That one has a dual clutch transmission that's operated by electric motors. So literally, it's kind of more of a manual. It's a dual clutch. And I noticed when I'm road testing it around, and I already delivered it to the customer, it was kind of like, it wasn't real smooth. You'd put it in drive and you'd kind of take off and it'd be like, vroom, vroom, vroom. It was like riding in a manual transmission car with someone who can drive pretty well. You know what I'm saying? Like they can shift pretty smooth, but it was not like an automatic. It's a little different. So that one literally is a dual clutch transmission, which functions just like an automatic, but it engages and disengages the clutches because there's two, an even gear clutch and an odd gear clutch. So in first, it's got the odd gear clutch engaged, right? Then it pre-shifts into second, but it doesn't connect that second gear shaft. And then when you want to go from first to second, it literally releases clutch one, releases the odd shaft and engages the even shaft clutch. And now you're in second. It pre-shifts into third, right? So it's kind of interesting. Again, though, not really been up to speed on ASEs, but when you see the electric motor type, that's a dual clutch. When you see the computer controlled hydraulic piston, that's a dual clutch. So for example, Mitsubishi Lancer Evo is a dual clutch, but it's hydraulic. Makes sense? This Hyundai was a dual clutch, but it was electric dry clutch with motors. Kind of interesting. Now we'll start with cable. Okay, cable. Actually, linkage is probably a little easier to understand, but the cable's more relevant. Linkage, we're just going to do a little bit on because there's nothing's using linkage anymore. It hasn't for a long time. So cable operated clutch, it's pretty simple. We'd literally got a cable going from the pedal to the clutch fork. That's to the release fork. That's it. If you look and basically follow the motion, you can see depressing the clutch pedal is going to transfer movement through the cable. It's going to move the fork. It's going to actuate the throwout bearing. It's so simple. Here you go. Clutch pedal is up right here. Clutch pedal is down right here. When you push it down, it pulls the cable. When you pull the cable, it's going to pull the fork, but it's going to pull the fork into contact. It's a little backwards from what you'd expect. So in other words, if you were to have the clutch pedal up, the cable's loose, the fork is going to be basically released from pushing up against the springs. When you push the cable, you're literally pulling the fork and the release bearing up against those diaphragm springs, for example. Okay. And this is where it gets a little bit tricky with this style, which is why it would not be my recommended design. As your clutch disc wears, this cable is actually going to get a bit tighter and a bit tighter and a bit tighter. Okay. Backwards from what people think. Like, oh, as the disc wears, the cable's loose, you got to tighten it up. No. As the disc wears, it gets thinner, which means the fork is going to actually pull more and that cable is going to be tighter. So if you were to do a brand new clutch and you were to set this up, you always need a little free play in the cable. Makes sense? When you release the clutch pedal, you should have a little bit of wiggle on that cable, on that pedal. You should be able to feel just a little wiggle. If there's no wiggle, that means it's actually pulling on the clutch fork and it's partially disengaging the clutch at all times. You understand? So how much wiggle room? I don't know. You have to look it up in service info. It might vary from vehicle to vehicle, but that clutch cable should never be tight when the clutch pedal is released, right? You're releasing it, the cable's tight. You should get to a point where, all right, the pedal's released and there should be just like a little wiggle room in that cable. Always some amount. I just don't know the exact amount. Now I want to cover that again. If there was no looseness, no wiggliness in the cable, no play in the cable when the pedal's released, that means it's already pulling the fork up against the springs. Think about what that means. If it's already pulling the fork up against the springs, is that disc able to be completely squeezed? Because the fork's kind of pulling it back a little. It's like, hey, I'm starting to disengage the clutch a little bit. What do you think that would cause for the customer? Let me talk you through it a little bit more. We're talking about the condition when the pedal's up. So if you think it's going to be dragging, clutch, the pedal's up, the clutch should be engaged. So don't think about dragging. Dragging is when the clutch pedal is down and the clutch is disengaged, but it's still engaged a little bit. It's dragging, right? If the clutch pedal's all the way up and we're accelerating, we need all the clamping force we can get. The problem is the pedal's too tight. So it's like, hey, clamp, but like, don't clamp all the way. Like, let me release you just a little. What's going to happen at wide open throttle? Come on, give it to me. Anybody know? No, you do. Wide open throttle. Clutch is partially disengaging because the cable's too tight. How do you think that's going to work out? Come on, it's a slip. Come on now. I could have offered some. Let me check the chat. It's probably in the chat, huh? No, it wasn't in the chat. You guys had too much fun at SEMA. All right, so think about what I said. Pedals up, accelerating, but the cable's too tight. And so the clutch is kind of like, yeah, I'm engaged, but like I'm gonna back off a little bit. Under wide open throttle, that disc could slip. If that disc slips, that's going to be a concern when my clutch slips. If the clutch slips, it's going to prematurely wear the disc. Make sense? So you'll cause premature clutch wear if this cable's too tight. So this is what happens. As it wears, the disc gets thinner and thinner. We need to continuously loosen the cable up, loosen the cable up, loosen the cable up. That's what we do. Right. To make room, you know, to allow that clutch to go, that release fork to go further and further in to make up for the disc getting thinner. So with that, some of these things are kind of fun. This cable actually attaches right here. And back in the day, we'd have to do adjustments periodically. It would call for an adjustment like, oh, every 10,000 miles or 15,000 miles, check clutch cable adjustment. So if you look like some old Celica, like an 88 Celica or something, it might call for a clutch cable adjustment as a maintenance. Then what we started doing is we started putting automatic adjusters. So this has an automatic adjuster. There's some teeth, and a lot of times they're plastic. And like as the cable wears and as things wear, it's almost like a ratchet. It'll click to the next gear. Well, we've had in the past where some of those teeth have actually stripped off. And the ASE was doing a type of a question that was saying like a vehicle with a cable type clutch is being worked on, and when the pedal is depressed, a pop is heard. You'd be like, what the heck, a pop? Well, just know there might be an auto adjustment mechanism in here that has little ratchet teeth, and they might be plastic. And if the teeth are worn or broken off, it can make a pop, especially if it gets to those worn teeth. So it's kind of a fun one. And then sometimes, though, I will say, as the clutch disc wears, we should loosen it. But especially if there's friction, the cable can actually stretch, right? So in the automatic adjustment type, we're also worried about cable stretching. And they do, and they can. It could go both ways. Makes sense. If the disc wears, the cable gets tight, but if the cable stretches, the cable gets loose. So we're trying to do auto adjustments so we don't need as much maintenance. That's been the trend since like the late 80s. It was sort of like, hey, we want to get less maintenance. Buy a Toyota because it's less maintenance than a Honda. Buy this because it's less maintenance, right? So you've been seeing a big push towards becoming less and less maintenance. Cool. So this is a little bit of a better view. When you push the pedal down, the cable gets pulled. When the cable gets pulled, it gets pulled this way, which pushes the fork into the springs. Kind of makes sense. So it's kind of interesting. And then you can see the release bearing right there. Pretty cool. You can also imagine there's going to be some sort of pivot, and you know, this is going to be external typically, but this is going to get some road debris and some stuff. So like this is type of things that will be exposed to the elements. So we can end up with a clutch cable having an issue. So I had about 2 years ago, a pretty good friend, electrician, he helped me with some of the tougher parts of my generator install, which by the way, I've got like 30-mile-an-hour winds, so I may lose power. The good news is I have a battery backup that'll be instantaneous, but the internal battery died. So if I lose power, I shouldn't lose internet this time. All right, so I'm prepared. So when I'm trying to do something and somebody has the skills that I don't have, there's not much I won't do to be able to, have them help me, right? So when he helped me with this generator, he's like, I need one thing. My old Nissan something, which actually came from Japan. So his son was stationed in Japan and he actually brought this car back over. It's some weird car. It's not even really like a super cool race car. It's just some car that you don't really see here. I think it's like an 89. It's old. He's like, it needs a clutch. And I said, yeah, that's on an older car like that. And it wasn't in the US. It wasn't in Southern California its whole life. It's probably gonna be rusty, but yeah, whatever it takes, I'll take care of the clutch. So I agreed to it. When I got there, I tried to actuate the clutch and it was like really hard to push down, but it also didn't really want to come back up. So I actually went and you guys can see in the picture, I disconnected the cable right here. If I disconnect the cable right there, that pedal should move super easy, but it didn't. It was like kind of binding up. So I knew the problem was actually in the cable. The cable itself it'll get water inside, and then there's like the outer casing has the little stranded cable in the middle, and if it's rusty in there, it gets too tight. You can press it down pretty well because you have all the leverage, but when you go to release it, sometimes it would get a little stuck, and he was having issues with the clutch not engaging, the clutch not releasing. It's hard to shift. Sometimes it slips. Like he had a whole list of clutch concerns and he came up with, it needs a clutch, obviously needs to pull the transmission. Well, I went down there and checked the cable and I was like, hey, Jose, this is just a clutch cable. I can't tell you for sure the condition of the actual clutch, but while this clutch cable is binding and stuff, we can't even really test the clutch. So let's get a clutch cable. It was like $20. Put the clutch cable in, did the adjustment, right? Because the adjustment's fairly simple. It's really just like a pedal free play. Make sure the pedal has 10 millimeters or 5 millimeters of free play, maybe a 1/4 inch of free play. Set it, and then I just said, yeah, just it feels good to me, but have your son drive it. He came back so happy. He's like, it hasn't shifted this well, like since I got it, and I thought it needed a clutch. And I've had the car here for like 8 years, and I didn't want to pay to have a clutch done. And I was sort of like, yeah, man, the whole time it's a $20 cable. Okay, so the cable can really throw you off. So in the rare event that you're working on something older with a cable, that's the best way that I would say to test it is eliminate the clutch from the equation and see how just the cable moves. Cool, that's what I would do. If the cable moves well, you could double check the adjustment. That's kind of the order of operation. We see if the cable's good, we check the adjustment. If the adjustment's good and the cable's good and it still has clutch issues, that's how you know you're gonna have to pull the transmission and go into the clutch. And then even still, if you're going to do that, I probably wouldn't say we need to pull the transmission to know what's wrong. I'd probably say you need a whole clutch kit. That's going to be a disc, a pressure plate, clutch cover, a pilot bearing, a release bearing, the little spring that holds the release bearing to the fork if it has one. And there's a good chance you're going to need a flywheel. And if they say yes, say while we're in there, we're going to check some other things. That's typically how we would sell the job. You may get in there and you may find that hub on the transmission is messed up, in which case you need to get a hub, so, but you won't know till you look at it. I'm just saying I wouldn't sell tear down time unless the customer's willing to replace all those parts. Cause if you go in there for a clutch concern, it's going to need a kit. If you just do the disc and then you get a noise 6 months later from a release bearing, the customer's gonna have a fit. And partially that would be like sort of your fault. Like it's not your fault because you didn't make the release bearing go bad, but you knew better. I'm telling you that you need to know better. If you pull a transmission to do something, you do the kit. And then you're gonna just have a lot less comebacks. Okay. You do the kit as a minimum, and if you find other damage, then you address the damage. Cool. Here's that pedal free play we were talking about. right? So it might talk about the pedal height, and a lot of times it'll talk about the free play. The free play is just easy movement. It's just kind of like this. Yeah, I know you can take the clutch and you can move it all the way, but you'll feel the difference. You'll feel like a little sloppy looseness before it starts to tug on the cable or before it starts to actually pump the hydraulic pressure. Makes sense? Kind of like a brake pedal. Did some of that stuff. And the adjustment point can vary. It could be on the cable itself, like back here. This is the adjustment point. Right here, there's like a little nut, and sometimes it's outside too, but there'll be like a little nut, and you can thread the cable and use the lock nut to lock it in. Or there could be a little linkage between the pedal and the actual master cylinder. So it's again kind of similar to brakes, except there's no booster, right? So we'll do adjustment points here. We're gonna go to a page, and then I want to make sure you understand everything I'm saying. So look, clutch pedal adjustment. If you have play, too much play, you could actually have a pedal that's lower loose, right? So you go to, I got that on the Jeep, right? I jump in and the first little bit of movement is kind of sloppy. And then, you know, I can feel it. I'll push it all the way to the floor. But when I go to first, it's kind of like a little hard. When I try to go in reverse, it's a, especially look, that's what it says right here. It's grinding and it's a hard shift, especially in reverse. Cool. Now I haven't even driven it yet. As soon as I did all that service and I went to put it in first and reverse, I was like, oh no, I got to get the clutch bled better. Okay. So too much play could be a pedal adjustment, but I didn't adjust the pedal. I changed the fluid. So too much pedal play is going to be the same as air in the system, right? Creeps at stoplights. So if I were to drive it, I put it in first, I put my pedal to the floor, and I notice it's kind of pulling me, right? I used a term for that. It's dragging me into the intersection. Cool. Not enough clutch travel. So that means like it's still partially engaged. So here I am, I put the clutch pedal down, the clutch moves some, but it doesn't move all the way. It doesn't move as far as it's supposed to, which means it's dragging. Dragging is clutch is not disengaged all the way. All these tests realistically are when we're applying the pedal. Remember, applying the pedal means releasing the clutch. So first one I'm going to tell you about is this Jeep. Air in the system will absolutely do that. If I move the clutch pedal back up to right here, remember I said I was going to do this. If I move the clutch pedal 6 inches all the way to the floor, I'm expecting the equivalent of 6 inches worth of travel and 6 inches down on the release fork. Now we're going to use piston sizes and leverage and stuff. So remember, this is a long lever, so it's not actually going to be 6 inches. I know that. Okay. But there's an equation there. So maybe let's say it's 6 inches of travel will make 1 inch of movement. Cool. If it's perfect and there's no air. If I throw the pedal 6 inches of travel, but the first 3 inches are wasted on compressing air, then my travel to the actual fork is only going to be a 1/2 inch. Then my fork is only moving halfway. You know what happens if you only push the pedal halfway and you try to drive, right? It's going to grind. It's going to creep at red lights. You might go to start it and have it turning the car, It's the same symptoms. Any symptom of excessive free play in your mind, you could think of, well, let me drive the car, but let me only push the clutch pedal down halfway. Grinding gears from a stop, it's going to be hard to get it into reverse if you can even get it in at all. But if you were to shut the car off, put it in reverse, and then start it, it would be in reverse. It would probably just be dragging. You'd be like, whoa, here we go. The clutch pedal's down, but I can't stop it. Make sense? That's all too loose adjustment. That's all too loose. In this Jeep, it's because it's got air in the system. I told you I had a friend, he wanted the purple clutch. Well, now I'm going to tell you a little bit more about that. He had to have the purple clutch, needed it, whatever. This was back at a time where I could have done his clutch. I was probably right about where you guys are at. It was like, I could do his clutch, but where am I going to do his clutch? So he's like, hey, I want my clutch done. And I was sort of like, dude, I'm not going to try to do a clutch in your Mitsubishi Eclipse in the driveway on my back. I've done that before. and I didn't like it then, and I certainly didn't like it now. And remember, I've told you there was a independent shop owner who'd hire me to do like some of the more specialty GM things. He'd be like, why am I going to do this water pump on a quad four that's timing chain driven? You do these, right? You could do it. And we'd come up with a price. So I knew him pretty well. And I told this kid, I won't even use his name. I said, hey, I'm going to set you up with my friend's shop, Automedic, and he'll do your clutch. And he gave me a price, $300 labor. So $300 is a good deal. And he gave this kid a good price mainly because I asked him. I didn't even have him ask him. I asked him. And now I'm a little older, a little wiser. I'm not going to put myself in that position again. If I've treated somebody really good, and they're treating me really good, I'm probably not going to insert myself between somebody who's been good to me and someone who's kind of an idiot. Make sense? Because he made me look bad here. So he says, yeah, do my clutch. I'm going to get the clutch. I'm going to get the purple clutch. So he gets the purple clutch, drops the car off. He's already kind of like being a pain. He's sort of like, well, I can't drop it off during the week. I need the car, whatever. I'll drop it off Saturday, and I'll wait. And the guy's like, dude, you're not going to wait for me to do your clutch. Drop it off, and then I'll call you when it's done. So he's already kind of giving him a hard time. To do a clutch, you got to pull the subframe, you got to pull the transmission, you got to pull a bunch of suspension stuff to get the axles out. It's not a small job. So he goes to do it, puts the purple clutch in, new flywheel, torques the flywheel to spec, torques the clutch cover to spec, lubes everything. Like, this dude's good. He's better than me by far. He's been doing it like 20 years longer than me. He owns his own shop. He knows what he's doing. Well, he gets it all together, and you push the pedal down and it's grinding. You come to a stoplight and it's dragging you into the intersection. Based on what I'm saying, what do you think is going on? That's like not disengaging the clutch all the way. So the diagnosis would be check the pedal adjustment. Well, the thing is, you didn't adjust the pedal. He didn't do anything with the pedal. The pedal adjustment's not really a thing. But that clutch isn't disengaging all the way. So he's sort of like, he comes to the conclusion of, hey, this clutch is no good. This purple clutch is a piece of crap. You can't be having no purple clutch. And so, but you could drive it. So the kid takes it. He's like, oh, the clutch is horrible. Your guy sucks, whatever. He brought it to another homie whose name was Don. And he was more like he knew some automotive stuff, but mostly what he had was a lot of time. Don was like working out of his garage and not real busy, and he lived with his mom. And so he didn't have a lot of bills. He didn't have a lot of pressure. It's like, yeah, bring it over. I'll fix it. That other mechanic is an idiot. I'll fix it. Don worked on the thing for like 2 days. He tried to bleed it. He tried to bleed it again. He called me and he's like, hey, your dealership is close to the Mitsubishi dealer. Will you talk with them, see if anybody's seen it? And I talked with the Mitsubishi guys, and they're like, a lot of times when people buy the clutch, they end up coming back for the slave cylinder or the master cylinder. And I was sort of like, okay. So I told Don that. So Don sends the guy, my dumb friend, hey, go get a clutch slave cylinder and a clutch master. He puts a clutch slave cylinder in it. He puts a clutch master cylinder in it. And basically the whole diagnosis was it's not releasing all the way. So therefore, the clutch slave and clutch master must not be throwing the fork all the way. So he does all this clutch stuff, and then he's like, well, it must not be bleeding. So he bleeds it, and he bleeds it. He spent like a whole day bleeding this car. And then he's looking at the fork, and like, if you throw the fork, it didn't seem like it was going the whole way. So he added little nuts and shims and stuff and tried to shim it up. And then at that point, it would actually, you could feel it in the pedal. You'd go to throw the pedal all the way, and the pedal would stop like an inch off the ground because it was bottoming out the clutch. He spent like a couple days on it. And then the kid came back to me like, hey, can you have your buddy at Automatics, fix this? And I was sort of like, well, didn't he tell you need to get like an OEM clutch and not the purple clutch? And he's like, yeah, and I'm ready because I've already bought a master cylinder and a slave cylinder and whatever and all this stuff. And so I talk with him. He's like, yeah, I'll help your buddy out, and I'll tell you what, I won't even charge him. I'll just do the job again, but he's got to go with OEM. I'm not gonna. There's no chance I'm going back pulling that transmission again if it's not OEM. So he bought the OEM parts. He put it in, and it was fine. Totally perfect. proved everybody wrong. And I was just thinking like, man, that guy is so smart. And he is, and he really is. But I understand where he's coming from too, is like when you have put all the work in and you're worth the money, you're not going to spend 2 days goofing off with this thing, trying to shim it, trying to replace parts and whatever. The guy who wanted to do that, who was kind enough to offer up, hey, he didn't even charge my friend. He's like, oh yeah, Don, I'll bring it over. We'll work on it. I'll work on it. He offered up like 2 days of his time, mainly because he didn't really have that much else to do. And he kind of likes it, a little more of a tinkering style. So when I first started, I kind of wanted to do tinkering. Like I'd be building that Honda Civic and whatever. Now, no, if I'm involved, the job's getting done. And if the customer's not willing to buy the right parts, I'm not going to get involved. There's no chance I'm going to do a job 2 and 3 times goofing around. I just won't. I've shifted from more of the Don guy who had fun working on it to more is now like every day I got to be productive with my time. Every day's I got to be able to bill a certain amount. So what you guys will find when you're new, it's kind of interesting and fun and you're willing to goof around a whole lot. But once your time is paying all your bills, it's really not likely that you're going to want to go and waste a day, working on it for fun, right? So when I talked with the guy who owned the shop, I was like, dude, honestly, that one had me a little sketched out. Like it's a brand new clutch. How could it be a brand new clutch and that be the problem? And he said, well, look, this is how I diagnosed it. When the clutch was dragging, I went down there with a pry bar and I shoved the pry bar in and I threw the clutch fork all the way as far as it would go. And it still was dragging. So we don't, if I threw it all the way as far as it would go, it's not because the clutch slave or the clutch master, the clutch pedal, it's none of that stuff. I've already thrown it as far as it can go and it still was dragging. So I don't care anything about the release mechanism. And I was just like, man, this guy's brilliant. And he kind of is, but it's not really that complex. And that's why I like to frame this up is remember the release system, all it does is release the clutch and it can only release it so far. And if it releases it as far as it's supposed to go and it still drags, there's like maybe it was actually like a stepped flywheel issue. So the ASE really gets nitty gritty on, let's say that the clutch doesn't disengage all the way, it drags, but it's, and you can measure the throw sometimes on the fork. It's thrown all the way, but it still drags. It'd be like, oh, that's got to be a problem with the stepped flywheel. Maybe it was machined wrong. But the ASE would say that it was machined wrong, right? Because people writing questions on the ASE, they've experienced the same type of stuff that I have. I keep thinking, nope, you got to get more parts. You're going to have to throw parts in. I actually was supportive of replacing the clutch slave and master because it made sense to me because the guy at the Mitsubishi parts department said, oh yeah, people come back for these. Like I was more inclined to listen to the parts guy than I was to listen to the owner of the shop because I had in my mind what I thought it was going to be. And I was just wrong. But I wasn't the one doing the work, luckily. So I was agreeing with the decisions, but luckily they weren't my decisions. They all would have been wrong. Now, Mitchell, I've seen your hand, so go ahead. Unless it's up by accident.
I was just saying, apparently, Roberto and Edward were having some internet connection issues.
Oh, okay.
Yeah, they posted it in the group me. I just wanted to let you know.
Okay, good. Yeah, we'll look at the recording. All right, so that's my extensive explanation of dragging, right? Dragging could be clutch pedals too loose. It could be air in the system, or unfortunately, it could be a defect with the actual mechanics of the clutch, like the purple clutch, or the incorrectly machined flywheel. That would be the step where they machined the step too much, but not the friction surface enough, right? All those will cause all these. And it's interesting because we spend a whole week on clutches and people like clutches, like you just talk about the clutch a little bit, but the problem is the ASE will really, they'll ask you a tricky question and you got to know it front side, back side, inside out. You got to know it from every different angle. So if it's after the work was performed, it's probably not because the slave cylinder was good, but now the slave cylinder is bad. Makes sense? That'd be more like the adjustment maybe, or maybe the incorrectly machined flywheel, or maybe a defective clutch part. Which is probably less likely on the ASE, but that was real life in this purple clutch situation. Now let's go on the other side. If it's too little, so what that means, the clutch is too tight. The clutch adjustment is too tight. So too much, the pedal's like this, sloppy. Too little, it's like, hey, this pedal's already pushing, right? So if we back up to here, you would have no free play. So too tight would be insufficient. That would be zero free play. You grab this pedal and you go ahead and you try to move this pedal, and it would be like already tight because it's already pushing on the hydraulic fluid because it's just too tight. Okay, what would that cause? Pedals hard and high, which probably the customer wouldn't really notice, but you might. It slips. What? I thought the release system wouldn't cause a slip. Remember what I was saying? It's it's really similar to brakes. If your brake pedal push rod was adjusted too long, that would be applying the brakes all the time. Makes sense? But the brakes stop, whereas the clutch pedal actually releases the clutch. So if the adjustments to like that push rod right here, there's actually a push rod right here, by the way. If this push rod is too long, think about it. It's going to try to shove your pedal up, but your pedal has a stopper. So rather than shove the pedal up, it actually starts to plunge this piston. And that starts to send fluid from this hydraulic master cylinder, pushes the fluid, pushes the slave pushes the fork. Now your fork is actually pushing up against the release mechanism, the throwout bearing, the release bearing, right? That's why it would slip. Your pedal's up all the way, but the problem is your hydraulic fluid is still down a little bit, which is starting to release the clutch. And that's why on wide open throttle, it'd be like slipping, right? Premature wear. The slip causes the premature wear. The noise, the noise is a little bit of a stretch for me, but it might be like because you're pushing on that release bearing all the time. Maybe you're going to hear a little bit more noise because the release bearing's not releasing. But the other thing is it's going to be too much travel and it's going to over travel the clutch. So when Don added a bunch of spacers in there, you'd actually try to push down and the clutch pedal would get firm like a brake pedal because it would try to throw the clutch all the way. It would max the clutch out and then it would actually build pressure and make your pedal firm. The only reason your pedal's not firm on a clutch pedal is because all your motion is throwing the fork. It's throwing the fork. If your fork were to be over traveled and bump up against a stopper, your pedal would firm up. And I know because that's what happened on this one. You do that for too long, you're going to cause some issues for sure. Right. So there's both of those. So once again, too little. The only likely thing that the customer is going to concern is going to most likely have a concern for is a clutch slip. She'll be like, "Oh, your clutch slips. You need a clutch." Well, not if it's too little pedal travel. That would make the clutch slip. When we do a clutch, for the record, we don't generally need to go in here and adjust this. If it's a cable, yes, but then the adjustment's mostly on the cable. If it's got this push rod, it's hydraulic. It's kind of like brakes. If we replace brake pads, we don't need to go in there and adjust that clutch pedal push rod. I mean that brake pedal push rod. We don't need to adjust it. There's no reason to adjust that. Leave that alone. That should not be getting messed with. We don't need to do that. Cool. Now that you've gotten mostly an understanding of the pedal and its adjustments, we'll apply this a little more specifically to hydraulics. You push your clutch pedal has a push rod, right? That's the one that needs to be adjusted right. That's probably going to go through the firewall. And then the clutch master cylinder is generally outside. There are some with them inside. Those are kind of a hassle. But now if you look at this, I'm going to throw like 5 ASE concepts at you because ASE's got mostly questions on hydraulics. If we had, let's just say, this is bolted to the firewall. If we had a firewall that was like maybe rusted out or cracked, do you see how that could make your clutch not disengage all the way? You'd throw your clutch pedal 6 inches. 1 or 2 of those inches would be wasted on the actual flexing of your firewall because it's rusted or weak or whatever, cracked. That would make the clutch not disengage all the way. Because how we disengage it, We throw 6 inches of pedal travel right here. That becomes 1 inch of stroke in this master. That becomes ultimately 1 inch of stroke on the slave cylinder. We shouldn't lose anything. If we do 1 inch of stroke on the slave cylinder, that's going to completely throw the fork 1 inch, and that fork is going to basically completely disengage the clutch. And it might not actually be 1 inch because it all depends on how much leverage is here, right? But we're going to say 1 inch for concept understanding. Let's just say that flywheel, that firewall was rotted out. 6 inches go to throw this, and let's just say we lose about, let's just go extreme. You lose 3 inches of movement because your whole master cylinder is flexing. Your whole clutch master cylinder is flexing. You only get a 1/2 inch of stroke. You only get a 1/2 inch of stroke. The clutch is still partially engaged. That clutch is going to drag. Okay. The clutch is going to drag you into the intersection, grind in reverse, etc. Make sense? Hydraulic issue? No. Rusted out firewall. Cool. That's been an ASE concept. Okay, I'll give you another one. This push rod is adjusted too short, and this pedal has 3 inches of play right here. The first 3 inches are play. The next 3 inches actually move it, but you only get 3 inches, so therefore you only get about a 1/2 inch of actual stroke in the clutch master. That becomes only a 1/2 inch of stroke in the clutch slave. That becomes, again, dragging, hard shifts, dragging you in the intersection, grinding going into reverse, and probably first too. Make sense? Reverse is always going to grind a little bit more because it's non-synchronized. First gear, it's probably still going to grind, but the synchronizer should mostly chill that out because it's synchronized in first, second, third, fourth, fifth, sixth, however many, seventh if it's a Corvette. Okay, now what about another one? Hint, hint. This is behind me now. If we have, let's say, a 1/2 inch of air in this line, we throw the clutch pedal 6 inches. This master cylinder strokes 1 inch. The fluid only moves a 1/2 inch because there's a 1/2 inch of air that gets compressed. So therefore the slave only moves a 1/2 inch. That would be grinding as well. That would be dragging. Makes sense? That's everything I just explained to you, all the same. All the same on a hydraulic system. Makes sense? This clutch pedal would be kind of low, right? It'd be really easy to move and then it would get a little better. So that's all this stuff right here. Too much, too much. All those symptoms. Too little. So much easier. There's only one. That would just mean literally this push rod right here is adjusted too long. It pushes your pedal all the way up. That's why it's hard and high. But more importantly, it actually pushes the fluid. So the fluid's already pressed. Your clutch pedal's up, but your fluid's already pressed, which means the slave cylinder's throwing your fork and your fork's already starting to release the clutch, even though your clutch pedal's up. If your clutch pedal's up and you're racing, but your fork is already kind of pushing on the release and your clutch is partially released, it's going to slip. And that's it. Okay, makes sense. All the other stuff is a drag, and a slip is just going to be caused by that long push rod adjustment. Insufficient clutch pedal travel or clutch play, right? Like right here we were talking about, the pedal free play would be insufficient. That's a slip. Everything else is a drag. So here's another angle. You guys can see pedal goes to the mat. Here's a fun one. You push this clutch pedal down. If this seal, right, because we don't have like a dual chamber, you know, this isn't a safety brake master cylinder. This is just a regular master cylinder. If this seal is leaking and you push the clutch pedal down and brake fluid comes out and gets on your toes, you know that it's that clutch master cylinder. Makes sense? So they could have some internal leak too, but they could also have a leak where it actually pukes the fluid out the push rod, and this is inside the car, so the brake fluid gets on your toes. It's pretty much how it works. Cool, that would be clutch master. Would it be the slave? No. If a slave is leaking, it might look like it in this picture, but that's outside the car. It doesn't drip on your toes, right? That's down here. A slave cylinder would drip on the ground. A clutch master might drip inside the car if the seals are bad. Cool. And then just remember, we have to check the fluid level right here. Sometimes it's kind of cool, but sometimes they'll tie it into the brake master cylinder reservoir, and then because they both use brake fluid, so that's kind of nice because you have access to more of a reservoir. These reservoirs are pretty small. If it's a standalone master cylinder reservoir, they're tiny. So we got to make sure we check that fluid, but don't overfill it. All right, so this is kind of talking about the internals. This is something you should be fairly familiar with. We were talking about, we have a primary seal and a secondary seal. Generally, if your primary seal is no good, it might struggle to make pressure. It's going to be like an internal type of leak. But if it's your secondary seal, that would actually allow the fluid to leak. I'm trying to get my mouse here. That would allow the fluid to leak past the piston, in by the push rod, and this is inside the car, right? This is bolted to the firewall, so this is leaking inside. So if you had a secondary seal, that'd be on your foot. If you had a primary seal, that would generally be just like it doesn't build pressure type of thing. Okay, and this is simplified. Sometimes they do have like the compensating ports and all that, type of stuff. But for a visual, this will give you a pretty good idea of what you got. When we pressurize, when we push this rod, we're going to move this piston. This piston's using this primary seal is going to scoop it and pressurize it and shove it out, the pressure out. Then when we release it, the pressure should come back in. And as the clutch disc slowly wears, it'll start to pull some fluid or add some, it'll go either way, but this amount of fluid should be enough for a brand new clutch or a thin clutch or anything in between. Okay, makes sense? And then additionally, this fluid needs to be maintained just like brake fluid. That clutch fluid can absorb moisture over time. So if you're doing a brake flush and it's a manual, it probably needs a clutch fluid as well. And these are generally self-adjusting, so we don't need to do any cable adjustments or any of that type of stuff. It's kind of like disc brakes. We don't adjust disc brakes. We do adjust drum brakes because those are a little bit different, but these are self-adjusting clutch systems. You back up right here, this is that push rod. So if we were to loosen this lock nut and turn this push rod longer, and they were to bottom the pedal out, now you can see how this push rod will start to push on this piston. And if it starts to push on this piston, it'll build pressure. And that'll actually start to release your clutch and cause a slip. So that's the same push rod. Whereas if we were to adjust this push rod smaller, your first 3 inches of travel would just go towards, nothing. It'd just be play. And then you'd only get 3 inches of travel here, which would become a 1/2 inch of piston stroke. And that's why you wouldn't release the clutch all the way, because you're only getting a 1/2 inch of stroke when you should get 1. That's going to be dragging, grinding in reverse, maybe grinding in first, etc. Okay. And then what that looks like on the car. Here's your internal slave. That was the concentric style. Here's your external slave. That one is kind of nicer because you can actually see it. So that Mitsubishi had this one. So that's what I'm saying. Jerry, the guy who owned that shop, he put a pry bar here and he threw this fork all the way. If you can throw that fork all the way and it still slips, it still drags, you're not really worried about this slave cylinder, this line, none of that stuff. Makes sense? So he was pretty smart. But the other cool thing with this, if you have a leaking slave cylinder, you can replace this without taking the transmission out. If this slave cylinder leaks, you got to take the transmission out because it goes around the input shaft. You need to be able to pull it off the input shaft. You absolutely need to have it out. Right. So just different design. In fact, this one, you'd have to pull the clutch disc and all sorts of stuff too. So different designs, positives and negatives of each. The negative of the external, this point right here is exposed to elements. So if it gets dried and, rusty and stuff, it'll squeak right there. It was really notorious on the Hondas. You'd go over it, you could spray some oil on it, and it would fix the squeak, at least for now. To fix it well, though, we should put the correct type of grease on the pivot point. Here's the bleeder for this one. Then remember, this one we send the bleeder out through the bell housing. Cool. So they use .3 or .4. You could use you could upgrade it to .4. It's got a higher heat rating, but .3 would probably be fine. Once in a great while, they'll have some abnormal clutch fluid. If it's mineral, it's a no. Don't mix them. Dot 3 and dot 4 can be mixed, but it lowers it to the standard of dot 3 if it's mixed with dot 3. Makes sense? So, but once in a while you have a clutch that'll use a different type of oil and it would specify it. So this one is saying dot 3, so we're good there. Cool. And then this shows a little bit more detailed of the master cylinder. Here's that beautiful push rod adjustment. Loosen the nut and spin that rod. If you turned it from this perspective, if you turned it up, that's going to lengthen it. If you turned it down, that's going to thread it in here and that's going to shorten it. And you would just be wiggling the pedal as you're doing that, checking the free play. But then you'll see what it actually has. It has a compensating port. So that's where it's similar to brakes. If you were to have that push rod adjusted too long, it'll actually move the piston. It'll block the compensating port. That's part of the reason the clutch won't release all the way. When the clutch pedal releases, the fluid is able to come back in to chamber B and ultimately vent into the reservoir. So if your push rod's too long, you can see the compensation port is going to be blocked and it's not going to, the fluid is not going to be allowed to release and go back into the reservoir. Right? Similar to brakes, if you recall. And then you can see this one's got a nice bleeder. In this orientation, this one will probably bleed reasonably well because the bleeder is up high. The only thing is, if you get some air and the air is like stuck right here, sometimes you got to work the clutch. You got to like move the clutch around and then try to get that air bubble to break loose and get the air bubble up here. That's a big part of why bleeding clutches is a pain in the butt. It's very hard to get the bleeder plug at the top. See, if the bleeder plug was up here, it'd be nice, but we need to bring the brake line in at that direction. So like they could be a bit of a hassle, especially if this piston is all the way extended. So sometimes this is what I saw. This was like a pro tip hack for you, life hack. When I did the clutch on mine, my mentor came over and he was like pumping the slave cylinder from the bottom. I was like, what are you doing? He's like, this is going to help bleed it. I'm sort of like, why? Well, it kind of made sense now. If there's any air trapped up against this piston and stuff, and you come down here and you're able to like basically stroke that slave cylinder and break that air free and get the air over here, while you're actually bleeding it, it'll help get all the air out. If air gets stuck over here, it's a pain. I'll give you an example. A Mini Cooper. The Mini Cooper has this thing at an angle, and up here tends to be like where it engages the clutch. This tends to be higher. So the air tends to get stuck at the end. They actually have a special service tool where you take the slave cylinder out and you put in this little clamp, and the clamp pushes the piston all the way back this way, and that'll prevent air from being lodged at the top. That'll actually push the air back here, and then when you bleed it, it's easier to catch the air and get the air out the bleeder plug. But without that tool, it's a hassle. So sometimes what we've done is unbolt them and wiggle them around, try to get the air to get up towards the bleeder and then continue the bleeding. It can be a pain. All right, so there you go. Just a little couple tips for you, the good ones. And then we've already kind of talked about the clutch operation, but now that we're on hydraulics, I want to talk a little bit more in detail. So in this case, the engine's on the right. When we send hydraulic pressure, the slave cylinder receives the pressure and transmits it into motion. And this is going to expand and push on the fork. And that fork going to the left will pivot and it'll push the spring. See, this is the pivot, and it'll push the spring to the right using the release bearing, right? So that's pretty much the motion. If you don't have correct volume of fluid coming through here, it's not going to move the fork as far as it's supposed to. It's not going to move the fork as far into the springs as you're supposed to in the release bearing. It's going to drag. Okay, so that's kind of like the difference. Make sense? So there's the releasing action. You can see it. Pedal up, pedal down, up, down, up, down. Now from the perspective of the clutch, that's released, applied, released, applied, released, applied. Okay. So at rest, it's like this. This release bearing is not pushing up against the springs. That clutch itself is applied. That would now be released, even though your pedal in this condition is down. See, so it gets people a little confused. Cool. And then here's that concentric slave. That one is centered. It's self-centering. A lot of times it bolts in. Sometimes it has a little bracket, but this one is in a way nicer. What they mean by concentric is this. If we back up, you've got the slave cylinder on one end throwing a fork, and it can tend to get that bearing hopefully straight, but maybe a little crooked. Okay. Whereas this one, we've got a piston behind the entire bearing. And this entire piston will move, and it'll really make sure that bearing is very centered and very flat and very true. It's a little bit of a more smooth movement. What's the effect? Maybe a little bit more even clutch application and release. You know, what's the cost? Now, if you need to change the slave cylinder and it's concentric, you got to pull the transmission. It's kind of frustrating for us, but in a way, if you think about it, more work isn't necessarily a bad thing. It's a little more frustrating if it's your car, but you're going to work on thousands of customer cars. And to you, it's like, well, it just means I can't do 2 slave cylinders in a day. I can only do 1, but I get paid the same. Makes sense? So this is going to pay a lot more than an externally mounted one. So I wouldn't be real frustrated with this unless it's your car and you're not getting paid to fix your own car. Then I'd be frustrated like that. Okay, now linkage, be pretty basic. Back in the day, we didn't have cables. We didn't do hydraulic. We didn't need to. It was like you sat up in a truck cab and the pedal kind of pushed down, and we could really simply use a little mechanism to apply and release the clutch. So they did have a push rod for adjustment, but it was crazy. That push rod would literally just go to like an arm, and the arm would move a shaft, and the shaft would move another little arm, and that arm would move the fork. That was it. This would just need, there might be like grease fittings or Zerks on here somewhere. And it would just need maybe periodic adjustment of the linkage. That was it. Super simple. But again, as the clutch plate would wear, you generally have to loosen up that push rod to account for it. Kind of similar to a cable. All right, but not real common. It's just, it needed a lot of lubrication. So like, this is the design. You'd have to lubricate these different various things. But back in the day, remember, we did LOF, lube oil filter. So you'd be lubricating the chassis, the steering parts, the clutch part. We were doing a lot of grease. That's why we were grease monkeys. We'd be greasing all sorts of baloney. Then the cable was less maintenance, and then hydraulics is even less maintenance than that. Self-adjusting and everything. Cool. So it's a little bit about linkage. Now, electronically controlled. This is a high-speed AC motor, and it's literally going to move the clutch inside the bell housing. It gets a connector right here. This harness goes back to an ECM, and the ECM will control it. Sometimes they have to have some sort of inverter or a converter, and that is not on a true manual. That's going to be on a dual clutch. So to put some perspective on this, I'm going to tell you where I stand, and I'm okay if we disagree, because I always like to hear, people's perspective, but I'm pretty firm on this one. So when we were thinking about getting a new car, my wife was really thinking GTR, and I was really thinking Camaro. And we were like having a whole big old back and forth. And the thing I told her to do was like, okay, when I'm at work then, and you have a day off, you go and you drive the GTR and you let me know what you really think. First off, they wouldn't let her drive the GTR. So that didn't help. They did let us drive the ZL1, so that did help. But she went to go drive the GTR, and I had told her they're automatic only. And she's like, no way, there's no way. Look at that car. It can't be automatic only. But see, I simplified it. I didn't explain to her dual clutch and all that type of stuff. So she went to the Nissan dealer and said, hey, I'd like to test the GTR. And they're kind of like, okay, do you want to buy it? And she said, I don't know. I mean, my husband says they're automatic only. And they're like, what? They're not automatic. They're paddle shift manuals. So this is kind of where I'm going. And it was sort of like the way the dual clutch transmission works, it is like a manual. It truly is. It's not planetary gear sets and clutch packs. It's literally gears on gears and a clutch that's going to be actuated in the GTR's case hydraulically, or in this case, literally mechanically. So the way we work on it is actually much more like a manual. And that's why dual clutch is part of the manual curriculum. However, when I get in a car and it says park on it, it's an automatic. As a driver, I'm done. If I can take it from park and put it in drive, that is an automatic transmission. So she checked it out and they're sort of like, you know, and then she's like, it says park and it says drive. And I said, that's my girl right there. So the salesman's sort of like, yeah, but you shift like this. And she's sort of like, where's the clutch pedal? There is none. And then she came home and she said, you know what? You're right. That's an automatic. I said, got him, like that. So from a driver perspective, the dual clutch is an automatic. Now, yes, you can shift it manual with paddles, but guess what? You can do that on a Camry too, just with the shifter. Trust me, it's an automatic, I can assure you. But the way we work on it's more like a manual. So as we go into the transmission itself, I want you to keep that in mind. Right now, we're just focused on the clutch. And so that's what I wanted to point out. This clutch can be activated, you know, engaged and disengaged by electronics only. And it actually works just like a clutch pedal, except you don't have to touch it. Computer will do it. Cool. So they have the fork can look a little bit different. The way they actuate and release can look a little different. So you can see this is kind of a bigger fork. And it's going to be operated by a motor. So kind of cool. They will also self-learn. So as the clutch disc wears and things change, it'll kind of learn the bite point. So if you have a manual and you have the clutch pedal down and you're lifting the pedal up, there's a lot of times there's some like room right there where it's like not doing anything. You kind of want to get an idea where the bite point is, because when you're trying to drive a little more quickly, you're going to like quickly release it to where the bite point is based on your memory. Then you're going to slow down and do a little bit of a fine gradual application, right? Well, these have that too, and they learn it. Cool. So it's pretty neat, and they'll do basically their own self adjustments as the clutch disc wears. Okay. How? Well, the TCM controls it. Now, how on the hydraulic ones? The TCM controls hydraulic solenoids, which controls the flow of hydraulic oil. It's got a piston. There's typically going to be 2 pistons and 2 cylinders, and one of them is going to be to the even gears 1, 3, 5, 1, 3, and 5, and the other one is going to be evens 2, 4, and 6. Okay, so this is hydraulic controlled wet clutch. So there's going to be 2 clutches in here, and each one is going to go to an even shaft or the odd shaft. Now the shafts aren't like this. There's a shaft in the center and a hollow shaft on the outside. So it's either going to grab the middle or grab the outside. Both of them will go into the transmission. This is going to be a multi-disc, right? So you can imagine you're going to be able to put a lot more torque through a multi-disc with 6 or 8 plates on it compared to a single dry disc with 1 plate. Cool. And so for performance, it's probably going to go wet clutch. This is only for dual clutch transmissions. We don't do, as far as I know, wet clutches with a clutch pedal. We just don't. All right. And then when we're talking about from here on out is the service, right? So we're good on the theory. Now we're talking about the service, the measurements, the inspections. A lot of times we have to measure this spring. So what you're seeing right here is we're actually measuring the wear that's in the spring, measuring the actual springs for where the release cylinder has hit them. But the truth is, if you're going to measure that and it's within the tolerable limits, are you going to reuse it? According to Toyota and Lexus, yes. According to me, why? Even if it's good right now, you know, a clutch should last 100,000 or more miles. So like, if you don't think it's going to make it all the way to 200, no, you do it now. This is the time to do it. This makes a lot of sense to do it. Okay. So by all means, inspect all this stuff, but I'm telling you, I'm going to tell you again and again and again. If you go in there to do something with a clutch, do the kit. Do the kit because you want it to last all the way until the next interval, which should be over 100. Like for me, I get 200,000 miles out of a clutch because I barely press the clutch anyway. Makes sense? So like if I go in there, it's getting new stuff because the clutch kit's not even that expensive. If you buy it individually, it's expensive. But if you find out who makes it, Ison or Luke makes a lot of factory clutches, Exidy makes some factory clutches, you can buy the manufacturer, the original manufacturer clutch kit pretty cheap, and then you can buy it from Toyota, same parts in Toyota boxes individually for like 3 times the price. So I just do the clutch kit directly from the OEM supplier. Cool. That'd be better for the customer. Now we're talking about measuring the disc. So again, a lot of times it'll talk about doing a tread depth measurement. Like for example, my hair, if I do a tread depth measurement, it's pretty low. Okay. But you could also be squeezing it to measure the thickness. So this is more showing the tread depth measurement, but there's also times where you actually measure the thickness. We'd also need to give a visual inspection, check the release bearing, turning it, moving it, how's it feel, any noise. But to be honest, this isn't how I would check it. I would check it while the car is together. I'm always preferring to repair a car that I'm able to drive first, because my road test can tell me a lot more than this. Sometimes those bearing elements are only slightly damaged and it'll feel good, but by the time you put hundreds of pounds on them, you'll be like, oh, there is a problem here. See, my road test would diagnose this better than the spinning and stuff. Okay, but we're still going to check it. If for whatever reason the car came in not able to drive, you're going to have to do the best you can with this. But again, we're going to do the clutch kit. So it's getting a new bearing. It's still nice to know if it was bad though. Like if they said, hey, we had a noise and you get in there and this bearing's all shot, you'd be like, oh yeah, this bearing was bad. We're going to replace it anyway, but I'm just confirming it was bad so you can feel good about it. Cool. Now this is what I'm going to do most of my tests. In the vehicle, not taking the vehicle apart, right? Back up. This is how you check a clutch disc. If it's out, this is how you check a clutch if it's in. So start the vehicle, get it up to operating temperature, block the wheels, apply the parking brake, shift into the highest gear, 5th, 6th probably. Slowly and smoothly release the clutch. What should happen? The engine should just as smoothly as you release the clutch, the engine should be like, done. It shouldn't be like, that clutch is slipping. If you got your clutch pedal out in 6th and it stays running, that clutch is wasted. Okay. So that's the way to do it. But and this is how you guys are going to do it, but how I would actually do it is a little more like this. Because this is going to put a lot more strain on the clutch, right? It's like a heart. This is sort of like, hey, the doctor's listening to your heart and going to do some tests. This one's like, hey, get on the treadmill, Tubby. Get up to speed. Let me check your heart. You know what I'm saying? And be like, oh, I thought your heart was good at idle, but now here at 15 or 20 miles an hour, right? I'm going to shift to 6th. I'm going to make, what's it say? A full throttle acceleration. If it's in 6th and I'm at 20 and I punch it, you know what it should do? If the clutch is no good and you see the RPM flare up, it's because it can't hold it. Makes sense. And that's going to be at wide open throttle. Cool. So on my car, on that Civic, when I did that test, I wasn't in 6th, but first, zing, the RPMs went. Second, zing, third, zing. And then I realized, oh crap, this isn't good because I'm not speeding up any. The RPMs are going up because it's slipping the clutch. And the transmission is not speeding up because the clutch is slipping. Makes sense? Now, if I wanted to do this even more aggressively, which sometimes I will, but I typically wouldn't do it for a customer. Like I do it on my own stuff. If I want to really see what my clutch is up to, I'll put it in maybe like, let's say I'm at 20. I'll put it in maybe like 3rd and I'll just push the clutch pedal down, redline it, and I'll dump the clutch. And what should happen if the car's got good power? Dump the clutch, meaning just shoot. Sometimes I won't even let it up. I'll just slide my foot off the side like this, wham, and that clutch is in. What should happen at 20 in let's say 4th, wide open throttle if the car's got a lot of power? The clutch should handle all that power. Something's going to slip, but it ain't going to be the clutch. That should just nuke the tires. The tires should be getting smoldered. If you can spin your tires at 20 miles an hour like that, trust me, that clutch is a choice unit. But if I go to do that and the tires hook up and the RPM flares up, I'll be like, ooh, this clutch is starting to get there. Makes sense. So I kind of want to know early how the clutch is. Makes sense. The expense is the tires. The other possibility is you do what the Mustangs do, leaving the meat, and you end up losing control and crash into people, curbs, medians, other cars, etc. So I'm not sure I'd recommend that third one. Just saying, that's what I would do on my own stuff. Now, when we're doing this work, you're going to notice we got the alignment tool. Remember, this is a good diagram of this. The alignment tool is landing in the back of that pilot bearing area, but it's also splined. So the alignment tool, all it is basically a replica of the input shaft. The splines of the input shaft, the inside diameter, the outside diameter, all that stuff to land in the pilot bearing. That's the only reason we use this special alignment tool. Cool. If this would be ridiculous, but if you didn't have this tool and you had two transmissions, you could literally cut the input shaft off and that becomes your alignment tool. Why would you ruin that transmission? I don't know, but you could. Okay, so that's it. It's lining the disc. Now, the reason though this looks kind of simple is because it doesn't have the cover. It doesn't have the throwout bearing. It doesn't have the pressure plate on there. So by the time you put the pressure plate, it looked a little different. Makes sense? So this SST is going in and splined up against the disc. And we're basically, as long as you can land it in the pilot bearing will center this thing. You're good. But unlike some of the Toyota front wheel drives, you won't have a pilot bearing. So you'll use the alignment tool, then you'll take a step back and you'll just kind of like make sure it's centered in the diaphragm spring. And then while you're holding it there, you start doing the torque sequence on the clutch cover on the pressure plate, right? 1, 2, 3, 4, 5, 6. And there's a sequence and there's a torque spec. That's a more critical torque spec. You torquing that, if you under torque it, not only will it loosen up, but it's not really setting the springs well. And the reason that there's a sequence is because we need to draw it in nice and flat. If you pull it down on one side and the other side, that thing may be sitting kind of crooked on the clutch and it's going to be wearing the clutch more on one side, which not to say one side of the clutch will be worn more because it spins, but it'll be putting more pressure on one side. That'll make a hot spot right there. That'll make a hot spot on the pressure plate and the flywheel. Cool, so we draw it in nice and square and then torque it in sequence to the spec. It's not that complex. And then we're going to use a multi-purpose, but I'm gonna add to that and say it needs to be a high temperature. So for me personally, I'm immediately telling you go with a disc brake grease. Disc brake grease is always high temperature, not just brake grease, because that could be for drum wheel bearings, but disc brake grease, good to go. At this point, a little bit right here where the release bearing sits, you can see that's the pivot point right there, kind of where the spring goes, maybe right here where the sleeve goes, maybe on the sleeve, and then actually on the input shaft splines. But how much? Not a lot. A thin coat. You don't want any of this grease slinging off and getting on the disc. You also have to remember, the more gobbly grease you have, the more that's going to get little clutch material and fibers stuck to it. So just a little bit goes a long way. I'd probably go with a glob on the pivot points here, but I'd be very light here. I'd be very light here. And I don't know that I'd even do this because this release bearing slides on this sleeve right here, or the hub. So I would just put the bearing on and slide it on there and move it around and make sure everything moves good. That's how you're going to hook it up. The good news for you, we got a clutch that you're going to practice on a stand, and I've even got like a how to check the flywheel, etc. So this is a job you can take your time and do really well without pulling a transmission, but you're also going to pull a transmission, put a transmission in. But when you pull the transition, put a transmission in, you don't need to do that clutch. We got a clutch for you on a stand. That's the same job. Okay. Cool. And then when we go to reinstall, you got to remember, we got to have that transmission nice and square so that input shaft goes right into the disc. If you have it crooked, you could damage the disc right here. One of the really cool things that you could do, where the bell housing bolts are, you can actually take some bell housing bolts and you could cut the head off, or you can get even longer ones and cut the head off and make them like a big stud, like a long stud would become a dowel. If you get those, then you can get the transmission up on the jack and you can get it on the dowels and you can slide it in, and the bolts will make sure it's aligned really well. Cool. So that's a little SST you can make for yourself. That's why they're saying with a guide pin right here. Will I do it like that? Probably not. I'm going to use the jack, but you guys have noticed when we're doing this engine work, I have a little bit of a better trained eye than most of you, where it's like, no, move the transmission jack up, move it this way, move it that way, and then they'll just be like this, just like this. Beautiful. You just say, if you're like, get in there, man, you're gonna mess it up. There's another ASE concept that's been on there where you look at that center hub of a clutch, and you remember how it has the spline? Well, that spline on one of these is like broke loose. Like you could tell that center hub is broke loose from the rivets. And there could be a couple explanations for that. One, probably the alignment tool wasn't used and you went to slide it in and the alignment tool or the clutch hub didn't align with the input shaft and the input shaft is over here or over here and you're just banging it. Bang, 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 like this. Get in there, man. Boom, 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 boom. You'll damage the clutch. And that was an ASE question. Other thing it could be is maybe a little less likely is remember the bell housing has the dowels on it. So if there's a dowel on the block and a hole in the bell housing to receive it, that's to make sure it's centered. If you were to have it off centered, that would actually probably break that hub as well. It just wouldn't necessarily be on install. It'd be like over time, it's constantly trying to pull it off to one side. So centering and alignment is a big concept as well. Okay. And then this talked about adjustments. So from here out, except for a couple slides, it's mostly procedures. Okay. So I won't cover every step, but I'm going to summarize it. And I want to especially look at the pictures are going to tell us a lot right here. Okay. So this is talking about how to do the adjustment. This one is kind of simple, but this was cable operated. Okay. So you can review the steps step by step. We're basically just checking cable free play, operating it, checking cable free play. Cool. Inspecting. Now bleeding, this one is kind of a hassle, but the bleeding can vary from one vehicle to the next. Okay. So old fluid causes issues. Brake fluid hygroscopic. Remember it absorbs water. Okay. So we can test it the same way we test brake fluid with strips. With an electronic tester, check the fluid level. This is using the tester to tell if it's any good, check the boiling point and whatnot. Inspect the lines, just like brake lines. Inspect the lines, inspect the hoses. Make sure they're not kinked or messed up. These have flares, just like brake lines. Cool. Pretty similar. Check the little boot. This boot right here has a specific job. The boot is going to keep dust and debris out from the shaft, which is going to protect the seal. This is on a slave cylinder. Similar on the master cylinder, right? But this is kind of like the brake caliper piston boot. The seal behind is protected by the boot. Similar, right? And then there might be, do some measurements. You're going to see how far this fork throws. And if it's not throwing far enough, it could be due to adjustment or it could be due to air in the system. And that's pretty much like when we get into bleeding, if you open the system up, you'll have to bleed it. If you're just doing a clutch and you don't disconnect the hydraulics, you don't have to bleed it. And if I can help it, I don't disconnect the hydraulics. I'm just going to pull it apart and replace the clutch just like I do brakes. I don't necessarily like to open up the bleeder on brakes either. I try to keep the system sealed so I'm good. Now, if there's a problem with the fluid, then that's different, right? Then, I don't necessarily do a clutch and the fluid, but if I'm doing a clutch and the fluid has something wrong with it, then I'm going to do both, then fine. Maybe I'll go a little bit of a different path and I will have to bleed it because I'm changing the fluid as well. Makes sense? So we don't always have a bleeder on some of these, for the record. And you can't have it be overfilled. A lot of times that cap has no good way to vent. So if you overfill it and the fluid gets hot, then the fluid can actually start to release the clutch slightly. That has been an ASE concept in the past, right? Makes sense. So it tries to release the fluid, but it's overfilled and the cap holds it in. So it actually starts to build pressure back and push the release piston. Cool. You could gravity bleed, you could manual bleed, you could pressure or vacuum bleed. Any of those. This is another thing that they've been doing, and I'm thinking about getting one. This is a reverse bleeder. This actually pulls from the brake container, sucks it up in a hose, and you pump pure brake fluid in the bleeder and you push it all the way up to the master cylinder. That's a great way to get all the air out. That's also probably going to make it so that the master cylinder overflows and you get brake fluid all over. And that's how I lost my hair. But also be careful of the paint. So you better, if it gets to that point, you better cap that sucker and get it down and degrease it and spray it because it'll mess the paint up, right? So there's a couple different methods there. Gravity is a little more typical. Going to fill the fluid. Going to go down to the bottom, open up the bleeder, use a hose or use no hose if you want. And then you're just going to basically let it gravity drip, bleed out, and then keep the fluid full the whole time. It's nice when you use the hose dipped into a container because this will make sure there's no way air can ever make its way back up into the system. But with gravity, it shouldn't be real possible. And then when you're done, you're going to snug the bleeder up, set the correct level, don't overfill it. Cool. And then if it's going to be just manual old school, you're going to literally suck out the old dirty fluid, fill the fluid level, just like last time. And then you're going to say, hey, Tony, jump up in there. Press the pedal down. You holding down? Yeah, it's down. Crack the bleeder. The pedal will probably loosen up just a little bit, but it's not going to go down because it's already down. Make sense? Close the bleeder. Hey, let the pedal up. Press it down again. While you're holding it down? Yeah, I'm holding it down here. Crack the bleeder loose, right? Just like manual bleeding of brakes. That's it. And then set the level. Pressure vacuum, suck the dirty fluid out. Fill it with good fluid. Use the vacuum bleeder just like we do on brakes. Hook air to it, hook it up to the bleeder, draw it out. Vacuum bleeding is neat. It's just sometimes you got to end up rebleeding it manually, so I'm a little hesitant. And then, of course, set the level. All those are possible ways to bleed it. And then when we get into a little bit more clutch stuff, a lot of times we're doing the road test and common problems, noises, pulsation, slippage. Okay, noises. I got a whole video I want you to watch on that. I've already described some, but I want you to watch more. Pedal pulsations, that's kind of like warped rotors. So we're probably looking at a warped flywheel. We can measure that. There's also a possibility that's oil leaking out of a rear main seal, in which case you'll have like kind of a slip stick. Those are very similar to like a chatter. Okay. Pedal pulsations is how the pedal feels. A chatter is like the whole vehicle. They tend to go hand in hand. So a pedal pulsation actually would really only be run out on the flywheel, whereas a chatter is the one that could more be run out, but it could also be the oil because that's going to give you the slip stick, right? But they typically go together. Cool. And vibration could be a couple things that could be like chatter, but it could also be more like it just has a driveline vibration, maybe because the clutch is out of balance, maybe because an issue with the dual mass flywheel or something. And then binding and drag, we've talked about quite a bit, and slippage we've talked about, right? This one, the pedal's out and the RPMs are flaring up. This one, the pedal's down, but it's dragging you into the intersection, right? So you got to know all those for sure. So with noises, again, I got a whole amazing video on this. Gets a lot of views too, because people struggle to understand this one. Pilot bearing, release bearing, and the input shaft bearing are the main sources of clutch type noise. Pilot bearing would be pedal all the way down. Release bearing would be varying sound based on varying pedal pressure. Transmission input shaft bearing would be noise only with the pedal up, no noise with the bearing, with the pedal down. The video explains them really well. Okay, and they can make some different growling. They could even make a squeak if it's kind of dry, right? So this was a throwout bearing that was worn, and it was making a lot of noise that would vary in intensity with pedal pressure. Cool. Here's your pedal pulsation. You can see it's hot spots and it's warped. Here's your slippage. That clutch disc is totally worn and shot. If you were to measure tread depth, this one is pelon. This one is totally bald. This one's shot. 30 seconds on that sucker, which wouldn't be measured in 30 seconds. A lot of time they measure it in thousands or millimeters. Okay, binding, let's think about that. Binding could be, you know, something is not moving freely. So like that clutch hub, sometimes that gets a groove worn and then that release bearing gets stuck on that groove. Clutch binding could mean a couple different things, but let's just say the disc was being stuck applied or stuck released, or it has a hard time transitioning, remember that clutch hub rides on the input shaft. And as part of our service, we clean that and we lubricate that with a thin coating of oil. Remember? So part of the reason I don't go all crazy on these is like, if I have an issue with one of these, I know I'm going to do a clutch. And remember, I'm going to do the clutch kit and I'm going to clean and lubricate all the right points. It's kind of like brakes. If you do a good brake job, you're not going to have these issues. If it has these issues, you're kind of just selling like a good brake job. Even if the pads have been done recently, it's like, hey, we need to redo this. You didn't cut the rotors. You didn't lubricate the right points. You didn't clean the right areas from rust. You know, it's that type of thing. Just doing the job well is going to eliminate a lot of this. Like this, however, would need to be replaced. This is that clutch sleeve or that hub right there. So that one would be no go. That one probably won't polish out. They can get it. This one had a release bearing that went bad and was bad for a while, and they just continued to run it. This is basically like a spun bearing. That's what was happening. That bearing wasn't spinning internally. The inner race was spinning on the shaft, and that should have never happened. All right, cool. So then we talk about vibration. So remember, vibration could be flywheel out of balance. It could be clutch cover out of balance. It could also get into those little torsional damper springs. Okay. But it may not be the clutch at all. It could be U joints. It could be CV joints. It could be engine mounts that are allowing your engine and transmission to pick up and change the drive shaft or the CV shaft angle. So don't necessarily jump right to the clutch, but just know it could be some clutch type stuff, but it could also be CV axle or drive shaft, which may be made worse by worn engine or transmission mounts that are allowing your powertrain to move and change your angles like we covered last week. That's why that combined unit is for both A2 and A3. Applies to both, right? And then chatter we're talking about, that's like a brake pulsation. Cool. We could even potentially have an engine crankshaft that has too much end play. So if it were to have a thrust bearing that was totally worn out, it could have end play. That can cause some clutch type stuff too. Cool. So binding linkage, maybe worn engine mounts, maybe misalignment, bent or warped disc. Friction disc is binding on the input shaft. Loose friction disc linings, that'd be all on the disc. So these are less common reasons. The most common that I see would be rear main seal leaking and soaking part of the disc in oil, but not another part of the disc. So it'd be a slip stick condition, or flywheel run out. Those are the two most common. Cool. Here's a grabby clutch. A lot of times what'll happen if it's got the concentric style slave cylinder and brake fluid leaks out, that swells the linings up. It's kind of like a leaking wheel cylinder and rear drums. It makes the drums grabby. Leaking brake fluid on a concentric slave cylinder soaking into the linings will make the clutch grabby. It'll be like on or off. You'll go to engage it smoothly and it'll be like, here we go. Customer complained about that. That's a legit concern. Needs a new disc. If you're going to do that, you're probably going to do the kit and you're going to find out where the brake fluid came from, which is probably the clutch slave cylinder. Probably do that too. Cool. So how to do that? Well, let's just say we're going to do clutch service, 11 slides right here. I cut some of them, but if you're going to go and loosen the flywheel, for example, do you notice there's a match mark right there? That's a best practice, just in case the engine and the flywheel have been balanced as an assembly, which wouldn't really be that common, but you could. So make sure we mark that. And then we get in there to do that pilot bearing. This is the tool I'd recommend. You could use the grease. You could use the bimbo bread, but I would probably use this one. This would be the go-to for me. And then when we go to do that, you can see those jaws need to be small enough to grab the inside. And then this will be on a slide hammer, pow, 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 or it'll be on a threaded puller. It could be one or the other. Sometimes the threaded puller will actually go right through the middle and bump right in the back of the crankshaft and basically pull it. They vary. Slide hammer is more typical. And there you go. You can see it grab the outer race. If you can get it all the way to the outer race, you'll pull it in one rip. Sometimes you'll pull it and the center race will blow out, and then you get the rollers out, the ball bearings, and then you might have to go back in for just the center race. But whatever, the only reason you're doing this is if you're replacing it. So if you mess the old one up, getting it out, it's not that big of a deal. You're throwing it out anyway, right? And so then this one you can see is pulling it out pretty well. This is showing you should get this placement all the way on the outer race, and this one's actually showing pulling it, right? And there it goes. And then if it's a concentric style, this would be the slave cylinder and the bearing. But if it's a external style with the fork, this is the release bearing. So right here, we're pulling the bearing off the sleeve. It's a good idea to actually move it, see if it moves smoothly. After we do that, we need to inspect the flywheel. Look at the ring gear, look at the friction surface, look for hot spots, which would be indicated by bluing or like dark spots. Measure the runout. I got a really extensive video on how to inspect that flywheel. Okay, so you're mostly going to watch that. If they're designed with a step, just remember that depth of the step is critical to the operation of the pressure plate. So that means if you inspect it, you determine it can be resurfaced. They need to, you might want to do a measurement and make sure that the machine shop machines it to the same step. So if you're really sketched out, measure that step and find out how much it is. Then when you get it back, measure it, make sure the step is the same. Cool. But hopefully the machine shop's decent. When we're doing the work though, you see this clutch material, we're gonna clean that up. This is not exactly an ASE concept, but how you want to clean that up? Blast it with some air, because then it's in the air and you're going to breathe it. So it's actually better to use that blue roll around brake parts washer and clean it out with the brake parts washer, because that's going to grab the dust and the hazardous, these are probably going to have mostly like ceramics and carbon. It's not likely to be asbestos based. Okay. So some people will be like, oh, there's asbestos in there. Man, they haven't been using asbestos since the 70s. So unless the car's a 70 something, it's not going to be asbestos, but it's still bad for you. Okay. So getting it wet is going to kind of trap those particles and kind of rinse it. A big part of doing a transmission, like a clutch, is going to be a lot of cleanup, especially when the clutch is really messed up. And you do need to clean it. Like this is a little bit more for looks. You still need to clean it, because if a customer, it's just not a good job if you don't clean that. But also when you take something apart, you're going to look at that and be like, whoa, something's wrong with this clutch. But if it's from the old clutch, not the clutch you just did, they might be blaming you for something. It was really just something you didn't clean up, right? It's like residual oil after an oil change. But additionally, on some of those parts, we really need to clean this. Like you can't be having clutch dust on a lot of these parts. This all needs to be cleaned up, especially on the input shaft and that hub, got to be clean. This one, for example, be no-go. This flywheel needs to be redone. This is actually, might be a flywheel. This might be a pressure plate, but let's just say it's a flywheel. All these blue spots, that thing's done. You're not gonna be able to resurface that. They're gonna be hardened. And then you can check the straightness with a straight edge, but what I would really do is the dial indicator. Got a really good video on that for you. Okay, and again, looking at the ring gear, because remember I said I had a friend who overheated it so much this ring gear spun like this. It was just going around and round. And that was the cause of his crank or no crank, depending on how you looked at it, no start. Additionally, we want to look at this because if you have a starter issue and you end up needing to replace this flywheel, it'd be good to replace it now and figure out the starter issue. So just get in the habit of looking like back in the day, we'd have starter that wouldn't be hitting the right depth and it would be riding on only half of these teeth. And you'd end up wearing out half the flywheel teeth. And then all of a sudden it wouldn't start. It would just grind. You should fix that while you're in there. You should at least stop what you're doing and say, hey, we got an issue with a starter here. Let's replace the flywheel, but let's also figure out what's up with the starter, even though you're in for a clutch. Make sense? Okay, and then again, make sure it's secure. Like I was saying, you might inspect the starter as part of the job. Inspect the holes, make sure they're not damaged, etc. Now, this is going to go through run out at end play. It could be either. We're going to use the dial indicator. This is clamped to the block. The snake is going over here towards the flywheel. We're going to do two different things right here. One, this dial indicator is on the friction surface. So as we turn the crankshaft like this, that's going to measure runout. If the runout's out of spec, it needs to be replaced or resurfaced, just like a rotor. But the other thing is, and the ASE can ask you the difference, right? If they show you like this and they show the crankshaft turning, that's runout. That's flywheel runout. But if they show the flywheel going like this, that's actually crankshaft thrust or end play. See this? So this one is turning. This, by the way, is a special service tool to grab the teeth and turn a flywheel. That's a flywheel turning device. So that's runout. This one, and it would be probably even better to not put it on the flywheel. It'd be better to put it right on the crankshaft. You could do two things right here. One, you could turn it. So if you had runout on the crankshaft and runout on the flywheel, the problem would actually be the crankshaft. If you had runout on the flywheel, but then you put it on the crankshaft hub and this crankshaft hub was true, and it better be, then it's just the flywheel. Makes sense? So they're just saying like a crankshaft with a bad flange could make the flywheel have run out. Okay, even though it's not super likely. Then the other thing is, in the same spot, we're not going to turn this. We're actually going to try to push this crankshaft down and pull it up. That would be checking crankshaft thrust, right? That's checking our thrust bearing. And that, like they were saying, that can cause some clutch chatter because stuff is moving around. I don't think it's super common. A crazy thing I've actually seen is that thing having excessive thrust and it causing an intermittent stall when you depress the clutch pedal. You're like, how? Why? Well, when you push the clutch pedal, you put force on there and it would actually move the crankshaft, and the crank position sensor would be reading a reluctor wheel. And when you push the clutch pedal, it would move it and it wouldn't read it and it would die. And then you'd restart it and it'd be good. And you'd push the clutch pedal and it would die. And you're like, how can the clutch pedal do that? It was actually a worn thrust bearing. So kind of rare, but it's an interesting concept. Cool. So right now you can see we're prying up and down. So that's end play, which is really an engine issue, but they overlap a little bit. Cool. And then, we can get ready to do the clutch, look up all your specs, get all your sequence, all that type of thing. Drive that new pilot bearing in using a correct driver. Lubricate the pilot bearing once it's in. I'm not sure I would use, I don't recognize this yellow stuff, but in a clutch kit, sometimes it comes with a lubricant. If it came in the clutch kit, good to go. If it doesn't, my default is disc brake lube, like silicone paste would be fine. Or that purple stuff, that would be fine. Right? Line up the marks so you get your clutch, your flywheel back where it was on the crankshaft in case there was some weird flange issue, right? Like in case the flange had some run out and the flywheel was matched to it. I don't know. It's not real likely, but best practice. And then a lot of times those flywheel bolts call for Loctite. So, if it doesn't call for it, so be it. But if it does, do it. Clean the old Loctite off, put new Loctite on, torque them to spec, which is kind of a pain to do because the engine's going to try to turn. So you got to have a way to hold it. No comment on the impact gun. I'm just saying. There are a lot of times this is sequence and a torque spec. If you don't torque those correctly and it loosens up, you're redoing that job. That's a mess. Okay, and then clean it all off because look, you can't have any fingerprints on here like a rotor. Get it all nice and cleaned. Then we're going to set the disc on there. Make sure it's not backwards. Sometimes it'll say flywheel side or engine side. Other times it won't fit. And other times it won't say anything and it will fit, and you'll put a clutch disc on backwards and you'll find out. So pay attention when you're taking it apart. Okay. And then using the alignment tool, this is going to center it. So we can put the tool in right now, and that tool should land in that pilot bearing and it should center it. Then we're going to clean off the pressure plate. And then we're going to line the pressure plate up and see the pressure plate's nice because it slid right over top of the alignment tool. And then the pressure plate is going to be aligned on the dowels, and we're going to start them, and then we're going to snug them up a little bit, but then we're going to torque it in a sequence to the spec, and it might only be something like that, 15 foot-pounds or something. It's not a lot, but you got to have it in spec. And then if everything's gone well, once you torque those bolts, your disc is clamped. So now you can pull the tool out. And then once you go to install the transmission, it'll slide right in because it was centered, okay? But additionally, we're going to change that release bearing. They might call for grease in certain points. It might call for that spring. If it's got a spring, replace it now. Here's lubing that pivot. Again, with that nice high temperature grease right there. If you don't lube that pivot, that's the one that can go. And then you'd be like, oh, I need a new clutch, but you just did it 3 months ago. They'd be like, no, I did the new clutch. I just didn't lube the right part. So I look stupid. Kind of like lubing the guide pins and brakes, right? Installing the fork. This to me is too much lube. In fact, that's a lot of too much lube. There's too much goop in there. You might goop it like that and then wipe most of that off, or just don't put that much. Because this to me, you're asking for this stuff to sling off with centrifugal force and get on the disc. The disc sits right here. That's too close to the disc. And additionally, it's just going to get caked up a bunch of, clutch dust. Okay, so that's too much. Then when we slide the bell housing on, it's typically going to be the whole transmission. But in old cars, it was kind of cool. You could put the bell housing on and then bolt the transmission to the bell housing. So just remember, that was the part where it was cool if you had the studs, the guide studs, like dowels. But if not, just make sure you get it level and it should slide in like this. It should never be like this. Wham, 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 wham. Something's wrong if you're doing it like that. I can assure you. Right. And so if it's front wheel drive, you can see this transmission jack can get it up into place, but you notice that transaxle is not centered. That's why you can use these little knobs on the transmission jack, get everything level, maybe roll it this way, roll it this way, level it this way, level it that way. And it should just money. Okay. Very good. Very good. Like that. And that's kind of what's saying. Then you start the bolts and you shouldn't really have to draw these up with the bolts, but I will say, you're lining up the dowels. That was kind of what this was going for. You're going to line up the dowels, and then sometimes the dowels on the block fitting into the transmission bell housing can be a little tight. So I will use the bolt sometimes to close it up, but should already be all engaged, sitting good. I'm just having a hard time like pressing the dowel into the bell housing hole. I could use the bolts at that point. Only when I know it's lined up though, okay? And then snug it all up. And then you guys know we're going to put the slave cylinder on. Hopefully you don't have to bleed that because you never opened it. But if you did, you might have to bleed it. Do cables, half shafts, drive shafts, fill the fluid level if you drained it. If I'm doing a clutch, I'm not even draining the fluid level for the record. But if you did, cool. Sometimes it's got shifter linkage. Sometimes it's got a big shifter. A lot of it's really transmission R&R, by the way. But basically, you button this up. And if you have to bleed it, I'm sorry, but if not good, you should final check it with just verifying the clutch free play. If the free play is not right, think twice before you start adjusting because the free play shouldn't really change on a hydraulic clutch. And then of course, you're going to road test it, make sure the clutch grabs, make sure it holds, make sure it feels smooth, put a little bit of miles on there. And then some people would say when you're breaking in a new clutch, you don't want to be harsh with it. You want to be like, it's kind of like, breaking in the brake pads. They don't say to go out and get up to 100 and slam on the brakes as hard as you can. You kind of break it in with several smooth stops. It's kind of like this, like take it easy. It's going to be burning some of the residual oil off the flywheel and etc. Then after that, you're good to go. Got a new clutch. Now, if anybody's got any questions, I can take them because you made it.